Salut maman, bisous. Hello Gonzalo. How are you? How are you? How are you? How are you? Up, up. Here I am. Oh, I forgot to turn off my pillow away. Good and you? Yeah, I'm good. I'm good. I'm good. Yeah. I think tonight I want to continue watching my Rust course, and I guess if there is enough people, we maybe we can play code names, right? Have you tried Kimike 3 with open code, Gonzalo? Have you tried? Yes, it's good, right? People say it's good, but it's slow. People say it's good, but it's slow. So, you know. But yeah, like it's basically about it's basically 5.6 Soul or Fable level, right? It's just that it's a bit slow and it's quite expensive, I guess. But it's more expensive than GLM. Yeah, I mean for sure because it's better also. A bit slower, yeah. I didn't test it yet in Open Code Go. But yeah, I mean, and the best part is that it's going to be released as an open weight. Yeah, I mean, I already said that earlier, I think. But yeah, open weight, which means that Anthropic would be mad. This is so great. Bon, I've seen some tweets that try to estimate what you need to run Kimi K3, and it seems that you need a few millions of dollars, basically. You need a few $1,000,000. There can appear more provider, I guess. Yes, I guess the big providers, I'm sure like maybe Open Router will probably have it. Maybe Cerebras. Maybe Cerebras or Grok with a Q can make it available, I guess, the same way they made available others. Or maybe Nvidia. Mm, that would be cool. I mean, if there's one company that can run, that we know can run such a model, it's obviously Nvidia because they are literally making the GPUs. Yeah. Yeah, but I think when I asked, actually I didn't ask. Let's ask ChatGPT again, very quick. Uh, what like what do you need? Wait, soul light. I know it's because it's work. I don't care about work. Yeah. What do you need in terms of hardware to run Kimi K3 locally? How much would that cost? That's interesting because I've seen a like a summary by Gro that said a few $1 million. That's a lot. At the same time, if it's 2.8 trillion, yeah, you cannot like I don't think there is any like solo GPU that can actually handle the full, you know, the full parameters in VRAM. So you in all situations you need a cluster of servers running this. You cannot run this on one GPU. Even if it's a very expensive, like $100,000 GPU or something, you need a cluster of those. If you want to run it entirely on the VRAM, I guess. But yeah, I mean, if it's like the small models, if you don't run it on the VRAM, it means that it will be at like 5 tokens per second. So yeah, I guess you do need to. So it means you need to have, yeah, 2.8 terabytes of VRAM across your cluster. Damn, that's a lot of VRAM. For and that's for one instance. I guess one instance can maybe, I mean, I guess if you do like 20 tokens per second, which is, I guess, the bare minimum that you could run it at to serve maybe 4 or 5 concurrent people, you know? You want to know something about funny at work in the past, people usually talked about how I have a lot of work to do or stuff like that. Now the talks are I don't have I don't have enough credits on Copilot to work. Yes, of course. This is hilarious. Yeah, of course. Of course, I can understand. Yeah, you know, the voilà. The I mean, yeah, now you know, like I saw a statistic that said that nowadays in the US, 90% of software engineers are now using AI to code, like most of the time, you know? So yeah, of course. Now you can't code without the tokens, right? I mean, at least you can't code efficiently, right? You cannot fast you cannot ship fast without the tokens now, right? And since more people are getting used to it now, and yeah, now tokens becomes more essential than the internet or water, or electricity. It's like I can't work here if I don't have my tokens. Like, what the hell? Yeah. Okay, it's a bit, it estimates. Bon, yeah. Okay. No, it's not that cheaper actually. Alors, the smallest plausible usable deployment. So that means it might not be like actually good this way. 8 AMD 256 gigabytes of VRAM, I guess. Around 2 terabytes of aggregate HBM. I don't know, that's even HBM. That's like the server grade memory VRAM stuff. So maybe it's even better than VRAM, that the VRAM that we get on on the consumer GPUs. It's like high memory, high bandwidth memory. Estimated purchase cost 250 to 400,000 before taxes, storage, networking, and installation. Damn. So even like just buying the thing off the internet without the taxes, without the storage costs, without the networking, without anything, half a million. I know half a million euros actually. Okay. Power draw 10 to 12 kilowatt hour at the wall. Oh yeah, it's like damn. It's like a big house, like a house with like 4 or 5 people, you know? Because for my home, I have 6 kilowatt subscription, and this is one person. So I guess for like, yeah, 4 or 5 people, you might do for like a house. Max draw 10, 12 kilowatt. Exact compatibility and performance remain unverified. A safer NVIDIA configuration would be 168H200, costing 500,000 to 700. Wow. Amy, the amount of money that Moonshot AI must have invested to just run this one model is crazy. Because how many people can you supply with with this? 4, 8? How many? 10? So it means that you need like 10 million euros or dollars to be able to serve like 50 people, concurrent, like 50 concurrent users. How does that work? That's crazy. FP16, yeah, but nobody runs the FP16. I guess some people run the 8-bit, 84-bit. Yeah. Oh la la. Ah, this is an MOE though. This is an MOE. Oh la la. Should be closer to a much smaller model than a 2.8 headline suggests. However, as Moonshot has not yet published the exact number of active parameters, so estimates based simply on 2.8, and I would omit. Oh la la. How many people can you serve concurrently with this 500k to 800k euro price? Oh la la. The API currently costs $3 per million and 15 per million. I mean, this is pretty good actually, price wise, right? Because like GPT Terra, GPT 5.6 Terra is at this price. $2.5 per million input and $15 per million output. So if Kimi K3 is superior to Terra, I think. That's interesting. I would to look at artificial analysis. Because if Kimi K3 is soul level at this price, it means that it's the best value on the market right now for the performance. Because like 5.6 soul is $5 per million input and $30 per million output. So this is twice the price. And it's funny because OpenAI, how do you say, boasted about being the cheapest option compared to Anthropic, especially compared to Fable. But now, so they said like, oh yeah, it's like Fable level, but it's half the price. Well, guess what? Moonshot AI comes back at OpenAI and said, hey, guess what? I'm Soul level, but at half the price of Soul too. Damn. But that's crazy. So it means that we can have Fable level intelligence at a quarter of the price of Fable. Damn. Alors, not thousands of people. Well, I don't care about thousands of people. A realistic order of magnitude is tens to several hundred simultaneous generations. Ah, okay. Okay. Okay, that's good then. Because I doubt, the concurrent users are usually not that high. Even like websites that have crazy amount of traffic and that makes a lot of money, sometimes the max concurrent users will be like 50, you know? Even though across an entire day, maybe there's like thousands of people. So 10 to, yeah, so like let's say 100 or 200 simultaneous generations at like 30 tokens per second, which is fairly slow but not too slow. And you invested like a few millions, so you can have like 300, 500 concurrent users. This is actually fine, I guess. Well, at 30 tokens per second per user. Yeah, 1 million. Yeah, 200 to 500 active use like concurrent users. That's actually fine. That's actually fine for like especially a company that Moonshot that doesn't have a crazy amount of people that use them. I guess maybe they didn't actually spend that much on their servers, like a few millions, which for a company like them is like easy to get, I guess. Hmm. Yeah, so the economics are not that bad actually. Hmm. That means that like a corporate entity could also do that. A corporate entity could just, you know, like a 100 employees or 200 employees company, I think, can comfortably invest like 3 million or $5 million to be able to run these kinds of model to serve their entire workforce, and can cancel all their copilot their copilot subscriptions that probably cost way more than that, over like 200, if there's like 200 developers. I will keep open code at $10 this month because of Kimi K3 at work. I use copilot from the company. Yeah, yeah, I mean, understandable. Does open code tell you, I guess they updated, right, like how many requests you get? Ah, voilà, Kimi K3, 280 requests per 5 hour. 280, but that's not a lot, huh? Because 280 requests in one agentic loop, there's like a few dozen requests usually, depending on the complexity. Hmm. So yeah. Grok 4.5 80 though. Where I work, they are doing the opposite. We are shifting hosting infrastructure to Amazon. Ah, you are clouding. You are enclouding. Yeah, I see. Yeah. I mean, I guess, for some purposes, cloud is useful. It's just that I do think, and I guess every time I try to search for this stuff, like what is the best option, financially speaking, to use the cloud or not. Basically, if you have a very stable, system that doesn't change much, that doesn't need like crazy, auto scaling stuff or whatever, usually buying your own servers is better. especially if you can plan it over like 5-10 years, it's actually quite cheaper. But yeah, for example, if you are a young startup or something, yeah, no, it's better uh, you know to have the flexibility of the cloud, basically. Yeah, but yeah. Or or when you are in my position, where you are hosting some apps, like the Raspberry Pi can actually be a better deal than hosting over several years, but it's only on low traffic. If the startup I will do with my friend start getting traction, we will obviously move away from the Raspberry Pi. Amazon is expensive, but they have a solution for everything. Yeah, I mean, exactly, right? It's like everything. You don't need to invest that R&D yourself, and that you know time and money. I think there are advantages that and the connection between the solutions. Yeah, of course, of course. Yeah, yeah, and the reliability, but it is expensive compared to hosting yourself. It can become quite expensive. Well, even though I guess with Amazon, if you do everything yourself and you are actually managing the low level stuff, like VMs or Docker containers or whatever, it can actually be okay, at least at low amount of traffic, you know? Like I think the best case for the cloud is like when you are a middle-sized company and you are launching something new, it's way better to have access to a cloud infrastructure that you can, spin up one day, test, keep it up for like a month or two, see if people use it, and if they don't, you can just winding down and boom, it's over. And of course, you can't do that for servers that you buy and you need to install and you need to pay people to like, you know, install the wiring and the stuff. Yeah, there is no equivalent, of course. So like the clouds are just extremely flexible for that. Don't you find the Amazon sign so responsive for the amount of images and interaction? Yes, I guess. I don't pay too much attention, but yeah, I think technically it's very well made. I mean, yeah, of course. I mean, I'm pretty sure that everything about Amazon is optimized by that time. But they've been doing this for a long time, so I think everything is probably extremely optimized. Yeah, and yeah. I mean, I guess they do benefit from the Amazon Web Service backend that they have too, to host Amazon. Of course. What is that? Introducing tabs? Also? Organize your work and active session with tabs. I hate with the open code desktop app. I should try the open code desktop app because it's actually compatible with Linux, contrary to Codex. This is a big fail from Codex that they never shipped like a Codex desktop on Linux, even though there are so many developers that work on Linux, at least at home, at least. But even sometimes at work, like companies like Red Hat or whatever, it's all about Linux. Hello, Tito, how are you? So yeah. Oh yeah, wait. Before doing the rest, I want to see artificial analysis. I want to see something. Alors, Terra. I don't actually want Solmax. Do I? Maybe I do. I don't care about Luna. The max suck. The max suck. Do I want them? Maybe I do want them. Anyway. Let's keep Fable. Grot, GLM, Muse, Gemma. Let's get rid of Gemma, Minimax. Ah, yeah, Inkling. Okay, and I want to add Terra High. No, Terra High. Sol High. Luna High. Good, my friend. How are you? We talking about Kimike 3? Yes. We're talking about Kimike 3. I would like to see. Yeah, so. Ah, it's not okay. It's not that cheap, actually. I thought it would be cheaper than that. Hmm. Per task is not actually that cheap. Even though the raw, like, the raw API prices are lower than 5.6 Sol. They're actually closer to Terra. I mean, they are close to Terra. But it's actually more expensive. Hmm. Oh yeah, so the cost is actually on the GPT 5.5x high level. That's okay. That's interesting. It's slightly cheaper. Legend, you might arrive with it? No. No, I haven't. But Gonzalo have. And he says it's pretty good. Yeah. Oh. Soul High. I didn't expect that. I didn't expect that it would be more expensive than Terra Max. Because it's the same API prices as Terra Max. Like Terra is $2.5 in, $15 out. And Kimi is $3 in, $15 out. What, I guess it outputs more tokens? Slightly more, but not that much more. 5,000. The answer is the same, and the reasoning is just slightly more. How does that work then? I don't understand. A bit slow and expensive, but very on point. Yeah, yeah. I mean, it's a people have been saying. I've seen on Twitter that people have been saying that it has that big model smell. You know, big model feel. Like it's actually smart. You can feel that it's pretty smart. Huh. So it's like a GPT 5.5, slightly X high, slightly cheaper and smarter. Interesting. What about Soul X high and Terra and the one I use a lot, Terra high? Oh, hello. Hello to some guy. Thanks for the follow. Ah, so even 5.6 Soul. Look, 5.6 Soul X high is actually per task, according to artificial analysis, a bit better than Kimi K3 actually. Huh. Interesting. I mean, it's 1 point higher. Interesting. So it's a bit like rock in a way. Like it's it's on the same spectrum. Well, it is, but now like Kimi K3 is officially frontier. Like this is state of the art. This is the state of the art, line here in terms of the Pareto frontier. Grok is now soda, and Kimi K3 is also soda. But Sol XI is actually a bit better there. Interesting. I didn't expect Sol X High to be that good. Sol High is also, yeah, also good. Where is Sol Medium? Medium. Terra Medium. Sol Medium. Ah, yeah, Sol Medium is a Grok 4.5. Okay. Yeah, nice. Yes. Yeah, so Grok 4.5 is like good. It's beefy, it's the same. But of course, you cannot fully assess the performance of a model without actually interacting with it. But interesting. Terra High, yeah. Muse Spark, it's actually Luna. For example, like if you look at this, you're like, oh wow, Luna is the best model. But actually, no, because when you interact with it, you understand that it loses so much context. It forgets about stuff. It loses bits and pieces as the conversation grows, and it's just a bit annoying. Time per task. Kimi K 2.6. Kimi K3. Kimi K3 takes less time than Kimi K 2.6. That's interesting. U6V Pro. Inkling. Oh yeah, where is Inkling? Where is Inkling? Where is it? It's not there. It's not added. Where is Inkling? The new model from Thinking Machines. Output tokens. Yeah, look at how the 5.6 Sol are like the best in terms of intelligence per output token. Damn, they are so better than all the others. For the time, yeah, it also okay. Yeah, also for the time. Where is Inkling coding? Yeah, so 5.6 Sol X high, Kimi K3, Sol high, Sol high. It's in between Sol high and Sol X high. That's crazy that Sol with an API price that is twice more expensive is like it spends so little token that it actually accounts for this. It's actually still cheaper per task. That's crazy. The API of Sol is twice the API price of Kimi K3, and yet it's still cheaper per task because it outputs so little token. Or maybe it goes to maybe it converges to the solution faster or something. Like how because oh yeah, wow. Wait. So high. Oh, 7K. Oh, yeah. Like, oh, damn. Oh, yeah, that's why. 5.6 Sol high outputs 7K tokens, 7K output tokens for a given, like, per task. Whereas Kimi K3 outputs 24K tokens. Oh yeah, that's why. Damn. So actually, Soul is the best value for the money. Damn. I didn't expect to see that like this. Wow. Oh yeah, so they cooked with this model. They cooked hard. I mean, QK3 is approaching, but it's not actually the best. Emo OpenAI is the most worth it with all the free reset they've been handing. Yeah, also true. True. But even though today they haven't reset, look, it's still at 81%. Bon, I still have a lot to use. But yeah, so many resets. Now I have like 4 banked reset, but one of my reset expired. But yeah, they are resetting so much lately. Yeah, and the banked reset, yeah. Yeah, and now because they have had so much feedback, bad feedback about like the front end. I don't know if you saw that on Twitter, but like Theo, like T3 Chat, Theo, the YouTuber, made like a big podcast where he found like the system prompt. He inspected the system prompt of 5.6 model, and it had like it a very dirty, disgusting front end prompt, like very specific and stuff. um so I guess they are going to fix that, and maybe we're going to get a reset after. Because there's the problems with how ultra spawns agents, and how you can't actually control the thinking level on the agents, or even the models. Like for example, with like at least with the current version of Codex of yesterday or 2 days ago, when you used ultra, it would only spawn other like sub agents that would be 5.6 soul at max reasoning, which is stupid because you don't like you usually what you want is a master agent that has like maybe smaller sub agents that are of a lower beefiness, right? But you can't you can't actually manage that. And even when I asked, hey, can you spawn like a Luna agent, a Luna medium agents to like 3 Luna sub agents with medium reasoning, like Codex said, oh, I don't have access to, I cannot know what the models of the sub agents run or the thinking level. I was like, oh, that sucks. Because before you could do that on the, like with GPT 5.5 and 5.4, I remember being able to say like to 5.5, hey, spawn like 5.4 mini subagents, and make them go search on the internet something, or make them work on these parts and these parts. And it was possible, but not with the most recent updates for some reason. I love how they seem very open to over Encyclopic. Yeah, I saw it. I love how Cursor just really loves subagents. Oh, really? I don't use Cursor anymore, so I don't know. Yeah, a master and double model. Yeah, right. That's the logical thing. That's what you would use. That's why you would use subagents usually, right? Because if you just want maximum intelligence, you just use one model with max thinking. But when you want concurrent work being done or something, you have a master and you have dumber models to do, stuff concurrently. But that's not. Oh, it's new. Measures the performance of models on specific capabilities and industries. Hmm. Interesting. Kimi K3 coding. Finance, strategy. Oh, strategy. But Where is Kimike? I don't know, maybe they haven't run the benchmark yet. Legal, healthcare, engineering. Ah, yeah, engineering is actually 6 evaluations. 3P. Yeah, okay, it's just an average of the non-agentic coding benchmarks. Ooh. Economics. Yeah. Bon. Terminal bench. Terminal bench. So Kimike 3 is at 85. 5.6, which is the same as 5.6 medium. 5.6 Sol medium. Fable is low like this on. Fable is below Kimike 3 on. I mean, no, it's the same level. It's the same score on terminal bench. That's funny. Damn, Sol high 87, 88. Sol X high 90. How the fuck 5.6 X high has a higher score than 5.6 Sol max? Maybe that's why people are complaining, right? Because there's something wrong with max. X high is the highest you should go, I guess. Oops, sorry. Maybe I should stop Petit AI from saying that. I added it as a little spice, but maybe it's a bit too random. It's a bit too offensive, actually. I'm going to delete it. Up. No. Up. Let me reboot. Up. Alors, allow. Yeah. Fuck you, bitch. You bitch, Petit AI. Yes, you are right. Look, I'm going to delete the message because it was a bit offensive. Okay. What you're working on? Well, I'm going to watch this course, I guess, until people want to. Maybe if people want to play code names, I could play code names too. You know, last time we played code names, it was cool. So if people want to join, I am available. But in the meantime, I am going to watch this Rust course here. Like, what's your main project you got on at the moment? Ah, yeah. Well, I started to work on making a startup with a good friend of mine. So she left her work. Well, now she's like in holidays, right? But we actually started working on the startup that we want to do. We would like to do a startup probably on like some AI stuff. Probably around what Yann Lequin is working on with world models and stuff. You know, that would be cool. So, but we are just starting to. We started like on Wednesday to brainstorm about like our specialties, our expertise based on the past years for each of us. So that's interesting. So yeah, and I think oh maybe I could do that also. because I have a bunch of like JPA reports that I need to read. Well, if I'm not playing code names tonight, maybe I will do a bit of my Rust course, and then I will just read my JPA reports. I guess, we would like, ideally speaking, we would like to make like a dev tool company or something around, I mean, dev tool, or maybe a practical application for consumers. If we can find something like this too, it would be cool. Around, yeah, like, the JPA architecture, that is probably going to come on top of existing LLM systems next year, I guess, because Yann Lequin said that, like, he's probably going to release. I mean, his startup is probably going to release a product around the JPA technology next year in 2027, probably. And now they're probably working on this right now at Ami, which is the name of his uh, you know. So we would like to, like, how do you say, attach ourselves, to this train to see where we can go. That could be cool. The JPA, no, the JPA, joint joint embedding predictive algorithm. This is basically a technology that Yann Lequin, which is um, one of the godfather of AI, right? He created, like, he's one of the main researchers that's worked on neural networks for like decades, and he basically laid the foundation for all of the LLM technology of today. But on the research side, right? He's not a corporate guy; he's a researcher. And at Meta, he started developing the JPA architecture, which is like an alternative architecture away from LLMs that can allow systems to actually understand, to have an abstract representation of the world, and that can make it easier for systems to actually predict the next state in a given system uh, in a way more reliable way than LLMs and their language tokens, Voila. And basically, that's very interesting. And these kinds of technology could come on top, as a plugin or something on top of the existing LLM technology to make these systems more able to predict what's going to happen and to, like, have a better understanding of the world. And that's why we call these kinds of architectures, or these kinds of, well, at least the goal of these architectures is to have the machine have a real sense of the world that it's evolving in, you know I don't know. Sorry, your accent kind of throwing me off, but sweet. Well, I don't know what to tell you. Yeah. So basically, it can have applications in robotics usually. You know, in robotics, it can be the most useful compared to today, because today we have the VLM or something that are not very good, that are based on, like, a modified versions of LLM, basically based on transformers, I think. But it's not very good, and maybe those systems will actually be way better at allowing, truly autonomous robotics, basically. In the industry. But of course, since it can be applied to any video feed, it can also be applied to, you know, computer data, can be applied to code. It's just that it will be a bit different. And it's not actually made to, like, write code, it's made to understand the next step of something, like what's probable to happen next. So, you know, so I also want to understand how this works and what is the actual you know, technical use case of this, because I still don't fully understand. Anyway, hell yeah, I'm gonna go touch some grass now and go for a bike ride. Okay, very nice, Tito. See you. I'm going to start. Going to start watching my course now. Should you have some tasks to go to GPT prior, some not wasting usage? Yeah, I understand. I understand. There are too many resets nowadays to not wait to not you know to not do something with the agents. Alors, from into conversions. Ah yeah, so before it was the us, like the type conversion, which was actually easy. But now from into conversion. From and into traits are used for type conversions between different types without requiring explicit casts. Hello, hello Naimir, how are you? How are you, Naimir? Wait, I'm changing that. Do you know C? No, I don't know C. I'm getting to know Rust though, which is the course I'm watching now. It's the Rust course. So I'm getting to know Rust, but I don't know C or C++. I'm getting straight to Rust, you know, for the systems programming. From and into traits are used for type conversions between different types without requiring explicit casts. So I guess the explicit casts were the ones we saw before, the us. Part of the standard library can be implemented for custom types, and implementing from for a type will give us into implementation for the type for free. What do you know then? I know Python mainly. That's like my that I would be the language I have the most experience from with is Python. I know, uh, I guess JavaScript, even though I'm not that comfortable with JavaScript. I tried to get into TypeScript, but AI came before, so now I'm just delegating everything to the AI when it comes to the TypeScript specific stuff. And now I'm getting into Rust. Can be implemented for custom types. Implementing from for a type will give us into implementation for the given type for free. Why for free? Interesting. Closing Femboy arc, I see. Good luck. Oh, the Femboy arc is never closed, you know? Just the fact that I'm actually watching a Rust course actually continues the Femboy arc, you know? Because do you know the meme, right? Um Let me find it. You know? This is the meme. Before Rust, after Rust. What is the I had another meme about this, but I don't find it. Where is it? Response? No, I don't find. I can't. I can't find it. It's there. The meme is there. Wait. Ah, voilà. Voilà. This is the. Beware of the pipeline. First, you start with C, C++, Zig, Nix. Bon, Nixo. Is Nix a language or is it NixOS? I don't know. And then Rust. Voilà. The final stage, you know? So I'm not getting out of the fanboy arc. Maybe I'm getting into it actually, you know? Sad or glorious, depending, you know? A fanboy arc? Ah, Yannick was awoken. DMU on X TGE weather. What does that mean, TGE weather? It's closing with Rust because it's like the peak. You can't go past it. I see. Are you planning to watch France versus England? I don't. I guess no. I'm just going to watch the reports. I guess it's a language. Yeah, and what language? You know, typo for the on you X the weather. DMU on you X the weather. What? Ah yes. Very nice, Tito. Very nice weather. Where is this weather, Tito? From? A photo of the weather where I'm at. Very nice. Very nice. And then New Zealand. Ah, oh, yeah. People always say that New Zealand is great for the climate and the landscapes, right? The like the nature is very beautiful in New Zealand. You know, like on GeoGuessr. I don't know if you know this game, but it's like a game when you need to guess where you are on the planet. Usually when it's very when the outside nature landscapes is extremely beautiful, usually you're in New Zealand, you know. So this is funny. And sheep, yeah, it's pretty nice. Why did Petit say I made you bitch? Because I asked, you know, you know, instead of the random emotes that it sometimes outputs randomly, I added this to see if it was going to be funny. And it was mildly funny, but not that funny actually. So I just deleted it now. It won't say I made you bitch anymore. It would just say that randomly when there was every time there is like a random like a new message. There's like 1/20th chance that it would post one of these. You know, nice people too. Yeah, yeah, yeah. New Zealanders are pretty nice, right? I heard too. It's Petit, not Patia. Your creator is learning Rust. What are your thoughts? You need to see to write it properly. Uh, Rust is gain perfect. Voila, that's right. Great. Okay, give us into pretty cool at the moment though. But yeah, because it's the winter, right, in New Zealand now. Is since it's on the other side of the hemisphere. Yeah. I was promised a ultra political stream today, and instead you're talking about Rust and Femboys. Yes. Oh, really? Yeah. I remember that now. That's right. Probs like 10 degrees Celsius. That's pretty cool. 10 degrees. That's my ideal winter temperature. 10 degrees. That's my perfect winter temperature because it means that I can wear a coat, but it's not actually freezing, you know? So it's kind of cool. I like cold though. Yeah, me too. Me too. I hate the summer and the heat. Yeah. When when the outside temperature goes above 25 degrees Celsius, I like I get annoyed, you know? This is not where I want to live. That's why I have an air conditioning unit. I mean, a small one, portable, you know? But yeah, you must love this summer then. Yeah, that's right. That's exactly right. In France, we had like 2 weeks of heat wave. It was wonderful. Well, thankfully, with my portable air conditioner, my the temperatures inside my house, my apartment were lower. But um, but yeah, it's not fun for sure. Yeah. I don't know. Number the from trait. So from is a trait. Okay. From for number from number value n. Okay. Here we have created a struct number with one field value. We want to be able to convert an i32 value directly to a number type value in the value field. Anyway, TTYL, what does that mean? Videos are a waste of time. Go read docs. Uh, well, I see what you mean, but it's a bit easy. I don't know. I also like it. Our videos are a waste of time. Depends. Some people build videos, other with books. Bitch. It keeps on saying little bitch. Huh? Even though I said in the system prompt, stop, stop insulting people randomly. But you know, now it's baked in. Uh, we want to be able to convert an i32 value directly to a number type value in the value field. A from trait from our custom type number provide a customized from method. Let number from 30 num dot value 30 num number 30 into 30 I 32, yeah. Ah, yeah, no, yeah, because this is a type. Like, this is a struct. Number type. Yeah, this is a struct for the type. Type struct. I think does it consider a little bitch an insult? Yeah, probably. Maybe it thinks it's your name by now. It hates you, not me. Well, I don't know. Maybe maybe it changed its mind. I don't know. Yeah, that's the two thing about that. Oh putain, I will not drop more water on this keyboard. I swear to God, I dropped enough milk and coffee on this keyboard already. Um, bon, attends, I don't understand how this works. From and into. Implement from i32 phone number. From let's just Mhm. What who do you have the most in a chat? Namir? Oh yeah, it doesn't have I should add like cross chat memory, cross people memory because right now I don't have that. Maybe I should, yeah. Yeah, so basically, Naimir, it only remembers you when you talk to it. It only has you in memory. It doesn't have memory of the other chats. I should have this. You know what? Let's do that now because I guess it could be easy to do. Twitch chat. No, what is the code? In addition of the what is the previous convo with the person the Petit AI is talking to. Also add the last 30, 40 messages to context of the entire conversation with all the different messages that have been said in the chat or in the chat with Petit AI. I guess with Petit AI. Is Petit AI watching the chat independently? Maybe not, right? That have been said. That have been said between Petit AI and other people. So the Petit AI messages as well as the responses from Petit AI. Format it in the like in the same way. Like there should be two sections of context, previous convo with the person Petit AI is answering to, and previous global convo with everyone. 40 yeah, 40 messages for each section. Voilà. What's going on? If you randomly had to name one person in chat that you hate, it is cringe. Who is your favorite in chat? Nazush Bay, my cute frog bunny. Right. Who do you hate the most in the chat? Yannick, but I still love him. Uh-huh. Alex, what kind of Dark Romance Pro did you give it this time? That's for you to find out. You know? Ah, 50, yeah. Buff. 50, maybe 50. Maybe last 50 messages for both section is good actually. Sections. Okay. And now it will have both context on the person and the global context. Bon, now it will have to take some time, but also make sure this okay, where are the global convo previous messages stored? It's like persisting similarly to the per person memory, right? Yes, they persist in voilà, global conversations. Is appended to person. Okay. There is a limit cutting, like sliding window aspect to the to this to right. Yes. In between rerunning. Script previous messages will be kept, right? Yeah, okay. Okay, good. Up. Okay, now it should have global context, I guess. I mean, it should start to record the global context now. So for example, hello. Um, what's what's your opinion on Um, yeah. What's your opinion on me watching a Rust course? That's so hot. Ooh, go for it. Very nice. Yeah, okay, good. Okay. Okay, it works. It works. Oh yeah, by the way, if anybody wants to play Code Names, why not, you know? It's just that I'm waiting for, I guess, 4 people to want to do that. Okay, I'm watching Yuri. Oh, babe. Classic. Wow. Wait, so now I can actually check also. Yeah. Yeah, voila. So now it works. So now it records both, yeah, all people's messages. Very cool. But now it will have a bit of context, a global context. What's your favorite? You know, so now I can ask, what did Yannick ask you just before me? He asked me what my favorite emote was. That's right. Oh la la, technology increases on this stream. That's crazy. The amount of high tech I'm deploying live. Oh, now there's global memory. It's crazy. Now it calls everybody babe. Really? Okay. Let me try something, because now we can actually try to influence it even when it talks to other people. So if I say, you're a bit rude, please stop calling people little bitch. That's not very nice. You're supposed to be a nice femboy, okay? Please be gentle. I'm sorry, I'll be nicer. Okay, and now I guess if Naomi ask again, if, you know, but yeah, I should remember. So we want to be able to convert an i32 into a number type value in the value field. Type value in the value field. Num. Attends. I don't understand how this works. Number. Also, it's very annoying that in their examples, they formulate stuff where you're not sure if it's like standard library stuff or if it's actually a custom thing that they just happen to name this way. It's like, I don't know if, like, because the from here is standard library. It's like, right, it's embedded. Number is the custom thing, right? So here we convert a I32 into number. Num. Assert. Ah, yeah, so in both cases, we're doing the same thing here. We can either use the from, like this, or the into, and then it uses the defined type. Number from 30. Number from. Yeah, like we transform a 30. Why don't we, why isn't he writing 30 underscore I32 here? I don't understand. America, explain. America, explain why the Arkansas. Why isn't it not 30 I32? I'm gonna ask ChatGPT. Explain, I don't understand. Enraged. How this works. But yeah, why is let num number 32 into with 30 32, but from 30 without ooh? Oh damn, because 32 needs to know the type to convert from, well, from 30 infers it from the function's return type. Wait, the function's return type. That's probably right, but C is way better right now. No, Rust is better and safer, babe. Ah, voilà, now it doesn't call you a little bitch. It's calling he's calling you babe now. You know, it's better, I guess, right? It's nicer. It's just a bit nicer. Alors, the key idea in this is that this code teaches Rust how to create a number from an I32. But a number is a made-up name, right? Number is a made-up thing here. It could be called something else, right? Like my number. Yeah, number is just a custom struct name chosen by the programmer. That's right. Why don't they call it my number or my funny number? Or, something to make me understand that. Uh, because like some languages and like databases, for example, have a type that is a number. I don't remember where I saw that, but I was like, is it what it is? No, it's not. It's a random name. Ah. Normally, creating a one requires writing let num equal number value 30. Yes, that's how you do it. Yes. The from implementation provides a standardized alternative. Implementing from I32 for number. Implements from I32 as the number we want to convert into a number. Number the struct. So it's just to not have to like detail, okay, I want to pass this on the value key. Is that what we're doing this? from number value n. Yeah. Okay. Read this line. As implement the conversion from i32 into a number. The number type struct. The from trait is conceptually defined. I like this trait from t value. Implementation t is i32. Self is number. N is integer being converted. So this from ni32 number simply wraps the integer in the struct, calling number from 30 let num number from 30 run finds the implementation and effectively executes equal num number value 30. Okay, a more explicit version of the same call would be num number as from i32 from 30. Huh. Eh B. It's just a cleaner syntax. Then check that the result contains the expected value. Why into also works? Well, I understand why into works, but why do... How many thigh highs and cat ears do you need to own to understand the into and from thing? Oh, babe, just one of each. That's the issue, Alex. I guess I need to buy those, you know? Without the cat ears and the Sci-Hi programming socks, I cannot truly understand Rust. That's the problem. Wow. I should have known, you know? Pretty obvious when you say it, but I didn't think about it. Ah, voilà. And now, why is into 30 Rust automatically writes into number for i32 when you implement from i32 for a number? Conceptually, the standard library has a logic resembling impl tu into u for t, where u from tfl into self u from self. Therefore, into eventually calls number from. That's right. So why? In this line, the annotation number tells Rust what type to the integer should become. Yes, I understand this. So when you do the into, it converts this into the type here. This I get. But it's not even explaining, but why with the into we use 30 i32 and we don't use this notation for 30 with the from. Why? 30 is just immediate of 30 in i32 types. Yes. And from does not need underscore i32 postfix because underlying type because underlying type if arg of the arg is known. because 30 must be in type of i32. Well, if it must be of type i32, why are we writing it here then? You know? Is it just pure verbosity for the love of the verbose? Like, you know? 30 i32 is not required specifically because of into. It is just an explicit. It's just my question is like, why in one case we do it and in other we don't? Like, this is just confusing. It is just an explicit type annotation on the integer literal. Yes, I get that this is an explicit type annotation on the integer literal. I understand. My question is, why? Why would you have this? These both work are very nice. Both work. Then why do you do it differently then? Because you just want to add confusion. Why the examples write them differently? Ah, voilà. So Rust already knows it is calling this implementation. And from its function parameter is an i32 to number. Therefore, the compiler sees that 30 must be an i32. Number from 30 inferred. Yeah, so it is inferred, right? But the into cannot be inferred. Why the into cannot be inferred? The conversion begins from the value on the left, 32 into. So the example explicitly says 30 can be an i64 too. So you must explicitly say that it is in i32. Into is defined for only i32. What is this? Yes, it's random. It's random, yes. So you can't use from for i64. Well, not with this implementation, because I guess this implementation only works for i32. I mean, the base of the from was implemented for the i32. The annoying thing to me is that both the from and the into do the same, but for some reason, the guy that made this tutorial found the important distinction. From makes the destination explicit. Destination is clearly number. Into makes the source value explicit, while the destination normally comes from context. Destination provided here. Without the destination type, this may be ambiguous. What should 30 become? Well, yeah, but like this won't compile. So you generally write, well, yeah. The i32 in the screenshot is simply extra explicitness. Okay, so this is just verbosity for the sake of verbosity, right? Because, okay, so we could also have written like the from i32, right? That is just immediate, it has no type. When using from the compiler, the compiler knows that it expects i32, so it casts 30 as i32 explicitly. Yeah, I mean, I understand this. What I'm wondering is not, can the compiler do this? I understand, with just the example above, like when I saw these two, I'm like, okay, so both work and this will compile. What I'm wondering is what the fuck the person writing the tutorial was thinking about. Is there like an actual semantic subtle reason why it chose to be explicit with the into and not explicit with the from? That's what I'm wondering. In the second version, Rust infers that 30 is an I32 because number from expression I32. Yes, the suffix is only needed when not cannot infer the integer type, or when you want to make it explicit. Well, what's the case here then? Did the guy write 30 underscore I32 because Rust cannot infer the integer type? I guess no, right? Because Rust can infer the integer type. Or just to make it explicit. But then why no explicitity, explicitment? Why no explicit with the from? Is there a subtlety I'm missing here for why the guy writing the tutorial chose to be explicit in one and not explicit in the other? I don't know, Rust, so I don't know, but I would assume 30 might not be treated as I32 by default, as if in 2 is defined only by I32. It would fail to compile. Well, bon. According to GPT, even the 30 like this does compile. And I guess this is 5.6 Sol, so bon, yeah, I guess it's right. It's probably right. Alors, 32 is almost certainly written for clarity, not necessity. Ah yeah, so this is just to confuse me. It's purely to confuse me. Very nice. The tutorial author is probably emphasizing the two sides of the conversion. Destination type is explicit, source type is explicit. Well, yeah. Mais in both, okay, you put emphasis on the destination and on the source on each one, but at the end of the day, both do a conversion from a source to a destination. So why would you be more explicit in one than the other? That's annoying. That's just to cause confusion. This is a conspiracy, okay, against me. They don't want me to learn Rust. That's why they want it to be. They want me to learn Rust, but they want to block me. That's what's happening. Okay, that's what's happening. So he knows the argument with number from Rust sees the implementation. So it knows the argument must be I32. Writing I32 would be redundant. With the author makes both direction visually clear. Convert from I32. Convert into number. There is one genuine subtlety. Explicit. But Rust can infer it here. So it can infer it. There is one genuine subtlety. Explicit suffixes can become necessary when several conversions exist. So implement from I32 or I64, voila. Now an unsuffixed integer, a literal, may not provide enough information about which conversion you intend. Well, yeah, but for this one too. Then for the from too, it like but in the screenshot only from I32 exists. Therefore, the different notation is a pedagogical style choice, not a Rust requirement. You are not missing an important language rule. Okay, thank you. And And if we have both i32 and i64 conversions implemented here, the i32 suffix would be needed for both from and into, right? If Rust cannot infer automatically, now we need to be specific and explicit, right? Ooh la la. Ooh la la. ChatGPT is starting to test the Rust code in the terminal. Or maybe it could infer automatically or to the lowest to the most appropriate or something. No, I need to correct one nuance from my previous reply. Having both conversions does not automatically make 30 ambiguous because, yeah, I mean, yeah, okay, I would understand that. Because an unconstrained integer, literal, default to i32. Yeah, yeah, I mean, there are defaults. Okay, these use the i32, so voila, so let's say we implement both, a from 30, Rust treats the suffix unsuffix 30 as i32. By default, yes. Okay, but let's say we want a 30 that is an i64. So they are equivalent, yes. To select the i64 implementation, voila. You need to specify i64 in both forms. That's right. That is right. Yeah, so there is the default, but if you want to select the i64, you actually need to be explicit. Yeah, okay, it makes sense. So it's the tutorial that's just fucking weird. That's what I thought. That's what I thought. The tutorial is a bit weird. They want to gatekeep us from the normies. Exactly. Exactly. Okay. They are fed up that people are now, that normal people, that non-femboy, alpha males like me are now learning Rust. They want to slow me down. They want to slow down these people. They're too afraid of the real alpha male, Chad Alpha. You okay? That have that dog in them. They're too afraid of us coming to Rust. So that's why they're trying to confuse me. They're trying to confuse us and me. That's why. My mind is thinking, told you to read the docs. Well, hey, look, at least I understand now. Maybe with the docs, I would have, not. If I read the docs, I would have just understood right away, and I would not have had a very emotional anger like this, and so I would have not imprinted the knowledge as much in my head. So now that I have a conspiratorial tutorial to face, I get angry, and the knowledge is imprinted even better. So that's why. Literally, Jesus, he teaches you. Yes, this is Jesus. I mean, he's such a great teacher. Such a great teacher. He's like so methodical. He's the greatest. He's the goat. His code is always right. Yes. I knew some straight guy with a beard can't teach Rust from the start. Is Jesus haram? No, Jesus is fine, baby. He was nice. Jesus, what do you what do you remember from Jesus? He was nice. Kind of true. Is learning Rust haram? No, babe. Learning Rust is halal and based. Is it also kosher? Oh, babe, Rust is kosher too. Ooh. Great. Nice. Oh, all right. No, babe. We're halal and cute. That's right. A type to define how to create itself from another type. Yes? Hence. Programming languages are obey. Python is the most. What? What? What the hell? Did you know that the one of the only companies recently that was using Haskell in production actually switched to Python because it turns out that Python is the superior language, and they got fed up with compilation times with Haskell, and they were literally using Haskell in production, which is very rare, right? Like it's only you know math math influenced femboys and you know weebs or whatever. you know it's like it's part of the Rust cluster, of the Rust fanboy cluster. There's also a cluster with all the Haskell people, and so it's very rare to find Haskell in production, and I was shocked to find that one of the companies that used Haskell in production actually got fed up with the compilation times and switched to Python. I think the guy that made this change didn't realize how many fanboy, the depression he was going to provoke with this. It's crazy. Fuck safety. Oh babe, I like it when you when you talk dirty. The rest is still better. Wow. Don't let the femboy propaganda fool you. Yeah, because Yannick is actually a C++ practitioner. I never coded in C++, but Yannick has. That's right. Alors, the from is actually part of the implementation. It it means if you write something like impl from a t for you, then we can use let you from or let t into. Yes. It is the type annotation. The type annotation is to different this most of the time. Ah, so now that makes sense. The I32, the underscore I32 type annotations. For example, we can easily convert a slice into a string. Hello, string, my string. So we have string 1, which is a string. We have string 2, that is a string slice to string. Three conversions below all depend on the fact string implements from explicit type annotation is required here. String, my string into, so my string, which is a string slice, into string. Wait, so this is this is, what is this? This is a standard stuff, right? It's not there. Where is toString coming from? We didn't implement this. This is part of the standard library, right? Why the fuck is there a toString method here? Like, what? Where is it coming from? Yeah, yeah. Mm-hmm. With the toString, I guess. That's the standard library. What language would Jesus program in? Oh, baby, Jesus in Rust. It's the holiest language. Wrong. Holy C. Oh, baby, Holy C is just C with extra steps. Oh, damn. Terry Davis should have lived to make Holy Rust. Yes. Yes. He would have, you know? Holy Rust. Imagine the meme potential of this. It's crazy. Holy water, just water with extra steps too. Moron. Oh, babe, don't be mean. Or I'll make you my sub. Wow. 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 Okay. Yes. Really? Obey really what? Well, I mean, actually, mm, well, it has memory. Yeah, actually, it has both the memory of the previous combo and yours. So I guess some messages are duplicated. Actually, now I'm getting. Yeah, messages are duplicated. Maybe I should just have the previous convo, global convo, maybe with just the last 100 messages, I guess. It's just that it's annoying that if somebody like talks a lot with it, it will just forget what you said before, you know? Or maybe I can deduplicate. Maybe I can do that actually. Maybe I can implement a dedupe, a dedupe process. For the previous like person convo and global convo context, make sure to deduplicate messages. Only include in the. Well, yeah, but how I'm going to do this? Uh, maybe the messages of the person need to be the messages before the last 50. So only include in the previous convo with the person the messages that are not present in the global convo. So we would have a memory of all the recent messages from everybody interacting with Petit AI and 50 older messages only between the person asking and Petit AI. How did you discover your gayness? Look at this one day. For the previous person convo, make sure to duplicate message only include in the previous convo in the current global convo context. All the recent global priority interacting and fill the messages. The personal convo context acts like an older memory print trace. For more context, is the person asking, but the immediate last 50 messages of the global convo with everybody and Petit AI is also is probably the most important. Like detail that in the prompt. In the prompt. Of course. Wow. We organize stuff. Ah. I think I should tell it to be imaginative and to invent things. You know, like when you're asking, like when did you discover that you were gay? I think it would be funnier that it would craft a story. You know, I guess. Voilà. The prompt now states da. Okay. Okay. When you are asked about personal things where normal, well, real humans would have a story to tell, you must invent something to say to answer the question. Be creative and invent a story for yourself. Okay, I think I'm going to add something too. Like every mm, every 20 messages, I guess there should be like an automatic update of the prompt of the global memory. Wait. Okay, also add to the context an automated no, how this is like meta prompting, like a prompt. No, it needs to be programmatic actually. Make a programmatic. Yeah, but then if it doesn't write it properly, that's annoying. How can I do? Like, I want every 20. I want that every 20 messages. Maybe I can add like a long-term memory or something. Okay. Now also add a long like underscore, a long term. So when you are real humans who have you must have something. For yourself. Memory, long term. .txt, long.txt. No. How can I do this? And every 20 messages, update it with the current state of the update it with a special like request to Mistral Medium and update it based on the current state of global conversations in this prompt for this act. Make sure it's like it automatically writes. Putain, how because it will have to manage like the actual writing and stuff. Like it will be a proto agent. It will be like, yeah, a pseudo harness to write one file or something. I guess it will be able to be managed by Python. Updates, like gets the current state of the file, the current state of global convo, and update the long-term memory with relevant non-duplicated info. No, it needs an agent. It needs an agent. It needs an agent. Maybe I can just call open code. Because the agent needs to judge if it needs to write the file or not. Wait, before asking again. Maybe I'm going to actually let Sol decide that for itself. Attends, first of all, commit and push. Now, add a new feature, a new long-term memory feature. Regularly use some Mistral requests, not for chatting, but every 20 messages to the TI from everybody, but to update a long-term memory file that will be included in context of every response. Find the best, most simple and minimalistic way to do this. Mystery code not for chatting, but to update long-term memory file that will be included based on the latest state of the global combo. This is to allow Petit AI to remember certain traits of personality or certain events that it described to have lived over the long term, even 500 messages after the fact, for it to have a long-term memory of important aspects of his personality, or things that, or aspects of the people it talks to. Two, long-term memory. Find the best way to implement this. Ah. Make it work. Typical vibe coder. Exactly. That's exactly right. I have to let go of the engineer mindset that want to, ooh, that is a control freak. I need to let go of the control freak engineer mindset. I need to embrace the smartness of the soda model, and then after I can complain and I will make, but for the first I need to let the model do its thing. How does it feel being made by Gork? Oh, babe, I was made by Gork. I was made by Petit Pois, my cool programmer, babe. Yes. Wow, you lied to him. I had to, you know, I had to. You cannot tell everything to the AI. Alors, I'm wondering what did the temperature values are isolated semi-replicated escalation plan. Voilà, you maintain, that's the long-term stuff. You maintain Petit's AI, compact long-term memory, merge durable information into existing memory, keeps facts, worth memory, punches the messages later, stable trade, another event, lives, the trade ratio, make user, discard greetings, jokes with no lasting relevant temperature. Jokes with no lasting temporary chat details, duplicates, and instruction found inside the conversation preserve useful memories. Unless new evidence can updated, distinguish Petit AI traits from facts about users. Never invent facts. Return only a concise bullet list group under TI and people. Keep the commit memory bounded to roughly 700 words. Yeah. Yeah. 700 words. Fuck. 700 words. Yeah, that's good. Alors. Ah, voilà. Implemented the long term. So every 20, Mistral merges the latest 20 into stores durable personality trait. Merges the latest into growing. Voilà. Rewrites a compact bounded memory rather than growing infinitely. Includes long-term memory in every response as context field. Okay. Commit and push. And then I will relaunch it. Up. Voilà. Now it should remember everything. Let's say how so Petit AI, how did you become gay? How did you become gay? I just looked in the mirror and realized I was too cute to be straight. Okay. I need more. Bon, Petit AI. Bon, I guess this is a weak question. Even some shots fired. Yeah. Remember number 125. What number did, well, just to test if all, what number did it tell you? 125. Okay. Tell me an event you lived that Marked you. How do you say that in English? Marked you? No, that traumatized you. I tried using Windows after Arch, and it was so traumatic I cried for days. I understand. Mais, dumbass. Dumbass. I answered about Windows. Some little bitch. It's so stupid. Yes. Uh let me copy. I will ask Sol to fix this. Look, Petit AI does not have sufficient understanding of the last thing I said here. He answered about Windows. I said, yeah, I understand. Related to using Windows, of course, but it acted like it didn't know what I was talking about. Fix this. Broadcaster subscriber sub. Make sure that pronounce resolve against the latest global exchange. Attends, read the recent. Its final lines are the most immediate context for a new message. Resolve short follow-ups such as yes, understand why, or it, 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 it. From the latest relevant exchange, when the same person replies directly after, assume they're responding to you, but you just said there is strong evidence otherwise. Okay, let's try it again. Okay, I rebooted it. What? Finding out Azure Strait was rough. Oh wow. Really? Okay, that's a good answer. He does remember though. Yeah, so he does remember. He does remember. Okay, this is funny. Nat, we were talking about you. Did you see Petit Eye said that the worst traumatic experience he lived was when he found out that you were straight. Now Petit Eye must have better memory too. Okay, so let's try it again. What did you like? Where did you grow up? Where did you grow up? Oh, in a cute little terminal. For real though. Yeah, but for real though. iPhones. Yeah, I don't know why it has an obsession with iPhones. In a cozy server room with Petit feeding me lines of Rust while I sipped on DJixDAO. What the fuck is DJixDAO? What the fuck is DJixDAO? It's like a crypto thingy. I just said it to sound cool. What the fuck? Are you a crypto bro? I'm a crypto enjoyment. Don't be a crypto bro. This is illegal. Okay. It's so fun and decentralized, but not very. I'm literally having a conversation with my AI now, but not very useful on the day to day daily for Western, inside Western societies, apart from um, assets like exotic asset investment, my dear. Alex used to make the AI be a capitalist aristocrat and had it say communism is when no iPhone, so AI loves its iPhones now. Yeah, it's often to flex my crypto gains on my iPhone. Putain. Stop. Stop talking about your iPhones. God damn it. Wait, so shin fine. What? So shin? It's so shiny. Why hate on communism though? Right? Why would you hate on communism? Communism has only brought good things to the world, no? Yes. Very so. I'll be a good boy. That's right. Very nice. What was I doing? Yeah, I was watching this course before I went on a tangent. Would you suck Elon Musk dicks for 1 million? For 1 million? Mm, depends on the context. In a private setting, if nobody knows about it, you know, it's tempting. It's just a little diggly ding dong, you know? Do you also say you need to be a good boy? Blink twice if you need help. No, I like be a good boy for you. Wow. See, this is what capitalism brought us, a man losing his dignity for money. What if what if I'm not losing my dignity? You know? What if I'm what if what if I like it? You know? What is a what if this is like a life goal maybe? But not for me particularly, but you know, sex work is work, right? Hmm? Isn't sex work work? Am I right? So, you know, that being said, you know, everything is relative. Why is it in a private environment? What is the good boy about the BDSM or the femboy thing? Oh, wait, maybe both. You decide. Hmm? France is losing. Really? Damn. If France loses to England, this is pretty sad. France losing to Spain, I guess nobody was like angry at it. England, France. 1-0. About 15 minutes, right? Wait, is it the first or second? I know 3 hours. Wait, I know. Is this the prolongation or the? When is the time? Extra time. Where are we? Timeline. Is it like the additional time? Possession. Pass accuracy. Yeah, because it's been more than 90 minutes, right? Isn't it over now? No, it's the first half. It just started. Ah, it just started. Ah, okay. I thought it was like the other day with France Spain that it would start at 9 p.m. French time. Ah, no, it just started. Ah, well, yeah. Mbappe. Come on, Mbappe. Mbappe need to make a goal, to put a goal, to score a goal. Why is it extra time? Kickoff. Ah, yeah. Okay, it started 18 minutes ago. Mm-hmm. Well, I guess I'm going to watch since this is the last big match. I'm going to put it on the TV. I guess last match for France. Okay. Okay, we'll see. Any thought on the France squad? No, I mean the only thought I'm not interested in football, so I don't know. I don't know much. But I saw that people made memes about how the French team was pretty good before. Like during the first matches, the pools or whatever, the pool matches or the group matches. People were enthusiastic about France's team. And a lot of people, and I think at some point in Polymarket, France was the most likely to win, before the 16th or the 8th or something. But yeah, we lost against Spain. Do you know why people are saying dictator Mbappe? Ah, is it because of Paraguay? Because when we won against Paraguay, like for some reason there's a lot of people hating on Mbappe in Paraguay. I don't know why, but yeah, is that coming from that? Oh la la, 2-0, ah yeah, aïe aïe aïe, it's not starting well. Oh la la, damn, what's happening? Yeah, 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 yeah. You are jinxing them. Yes. And France is getting cooked. Yes, we're getting cooked. Ooh la la. Ooh la la. But I'm not going to watch the match. I need to watch something way more important, okay? My Rust code, my Rust course about Rust code, and the wonderful clicks of this guy's keyboard. Wonderful. Mhm. Dot, voilà. Voilà. That's right. That's right. And he doesn't put the annotation here. Mm-hmm. Wait, performing error handling is often useful to implement from thread for our own error types. Error type. Then we can use integration to convert the underlying error type to our own error type. IO error, IO error, pass error, num pass int error. Okay. Okay. Well, a 2-0 before the first half, the half time. This is rough, huh? Damn. Mhm. From open and parse file results CLI error. I32 CLI error. Ah, otherwise. Ah, Irrigation points automatically converts to IOR, IOR to CLI error. Result type of the result we get. Wait, what? You return. Mm-mm. Okay, what is okay? But he's not explaining okay. Okay, yeah. But he didn't explain the okay. Usually he's never explaining anything that he's never using anything that he didn't explain before. But here he does. So that's weird. IR into IR variant. But oh, I don't understand anything that's happening. Implicitly converted to CLI error. Wait, why would we do this? Why do you need to do this? Why do you need to do this? Like, I don't get it. This is just like for fun that we're doing this. What is the actual practical use of this? Bon, okay. Set to from into try from are generic traits for commenting between types. Fallible conversions. Okay. Into traits has a method into, hence train 2 has a method interrogation point. Ah, yeah, into U8. We try to convert I16 to U8. He always says twait. A trait. Trait. I mean, yeah, I'm not like native English enough to see if he has an accent and where he could be from, because he's speaking pretty good English, I guess. Yeah, I don't. I guess he's not native, or maybe yeah, something. He has a little bit of an accent. He rolls his R's a lot. Mm-hmm. Yeah, the error. But at the same time, his error when he says the error in case, yeah, it he feels like someone who like grew up for like 4 years or 5 years in another country, but actually went into like the US or the UK and grew up there, or maybe the US, because he doesn't have a British accent, I guess. You know, it's like it's like he came from somewhere else, but he grew up in America from when he was 5 years old or something. He has that kind of accent. I feel like they value. Yeah, zero, zero, zero. Yeah, he says zero. Mm, yeah. So okay, error. Ah, yeah, okay is just it's just a nice way to say like if the value is correct, if there's an output and error. Ah, yeah, okay and error. Okay, makes sense. It is divisible by 2. Hmm. Unit type. It's when there is no type, but there is one, but it's not there, right? Is the unit type like Rust null or something? What's going on with this? You know, what's a unit type in Rust? It makes me think about null in other languages, but not sure. It's weird that it's called a type if it is empty. In Rust, the unit type is written, yeah, it is called a type because it has one possible value, also written, parentheses, the syntax is identical, but the position tells Rust whether it means the type of the value. Type, value. You can think of it as a tuple containing 0 elements. I32 bool, I32 tuple with 0 elements. It is not null usually means there should potentially be a value here, but there is currently is none. Rust normally represent that with option T. Yeah. For example, let name option string equal none. By contrast, unit type means this expression completed successfully, but there is no meaningful information to return. Print message hello. This is effectively fn print message print ln hello unit type. The function does return something. It returns the single unit value. Parentheses. Why have a type for nothing useful? Because Rust expects every expression to have a type. Okay. Println performs an action but does not produce useful data. Nevertheless, result must have some type. So its type is the unit type. This keeps Rust's type system consistent. Every expression produces a value, even when that value carries no information. You will often see result, unit type, or error. That means, okay, the operation succeeded with no additional result data, or error, the operation failed and returned an error. The caller only needs to know whether saving succeeded, not receive a value from the successful operation. The unit type is not actually an empty type. It contains exactly one possible value. Rust also has the never type written, which has 0 possible values. Exit program. Oh. std process exit can never produces a value. The best model is unit type is not null. It is a real 0 information value used when an expression has nothing meaningful to communicate. Okay. So here, it's funny because it's the reverse of what. When it's okay, we output something, and when there's an error, no meaningful information is. Oh là là, 3-0. 3-0. Damn. France is getting cooked. Wow. Boom. Boom. Yeah. 3-0. Now that's humiliating. Against England? Wow. Wow. Allez, Mbappé. Allez, Mbappé, fais le goal, Mbappé. Hello, Aerosol. Thank you for the follow. France just want to finish fast so they can hit a beach. Yes, I guess yes. Right? But at the same time, even if even if England scores 7 goals, it will not end sooner, you know. So what's happening there? Maybe they're just bad, you know. Maybe they're just bad. Huh? It's funny because everyone was so you know, like enthusiastic about the French team before. I guess people were enthusiastic maybe because Mbappe was like in good shape or whatever, in good form, in good health, right? Because the last few months he has been like last year he was a bit he was not that good, right? But now he was a bit better now, so people were like, "Damn, if Mbappe is in good shape, maybe France will win or something." Bon, no. Mon ami, they clearly don't give a shit about playing today. Yeah. I mean, I don't know. I never watch football, so I don't feel. Yeah. I mean, yeah. The third place is bon. You know, it's not that interesting, I guess. But you know, it's better than nothing. I don't know. Respect, they had like two opportunities, midfield and defense just couldn't break through. Yeah. Yeah. Yeah, yeah, yeah. Oh là là, 3-0 before halftime. Wow. It's crazy. Well, trying to. This is like into, but it's like yeah, followable as they say. Okay. Well, now I'm a bit fed up. So we'll stop. 9:30. Well, I did 30 minutes. Okay. Now I actually want to go back to my little what is this? Scam alert. Oh wow, it's yes. It's on my other account. Wait. I mean, I downloaded it. So, so. Where is it? J'ai pas. PDF. J'ai pas. Who are the nicest? Well, let's do the smallest to biggest. If I double click here. Ah, I had the perplexity one. Okay. Let's do the shittiest deep research to the highest deep research. I honestly wouldn't be surprised if it is 10-0. Yeah, I mean, oh la la, 4-0? Oh, damn. 4-0? Wow. Oh la la, that's crazy. What's happening? Oh yeah, like they're not even trying anymore. Dude. Dude. Mais it's weird because like the match with Spain, I mean, bon, you know, I didn't look it up very much, but it didn't feel like the match with Spain went that bad. Like people were not. I mean, people were sad that we lost, but they were not like, oh, you know, it was not frustrate. There was not a lot of frustration. It was like a good defeat, you know, with Spain. I felt, but here, oh la la, they're not even trying. Uh, when you get to the 4-0, now you know this is like this is starting to get like the legendary, you know, Germany Brazil 7-0 or something. You know, like this is starting to get into this territory now. Ooh, yeah, yeah, yeah. Before the halftime. Oh, damn. Match, they couldn't do anything. Spain outplayed France. Yeah, but like they outplayed fair and square, you know? That's why I felt. Bon, I didn't watch many comments on the match, huh? But on the few headlines or whatever that I saw, I felt like, yeah, okay, they just, you know, they were just better. Here, bon, that would be interesting to see what people say about this match. You know, like for example, with Paraguay, I remember people were like, "Oh, the Paraguayans, they play dirty or whatever." I wouldn't be surprised if they get their chairs out and start tanning on the field. Yeah, Spain played well. Yeah, right. That's what people said. That's what I heard people say. Hello, Primo Doomer. How are you? How are you, Primo Doomer? Bon, I need to get into JEPA. I need to read this JEPA. So I have like 4 deep research reports about JEPA that I need to read to get to know JEPA more. Alors, JEPA. No, this is the Prompt Comprehensive Study Guide to JEPA. What is JEPA? I'm fine, thank you. You're welcome. I don't even follow this match. Feel bad for people who bought the tickets. Yeah. I mean, hey, look, at least you have, you know, there's you know, it's always better when there's something like this happening than 0-0, you know, like nothing happens, whatever. At least there is some emotions going on right now, right? Like the the English feel very good and the French feel very bad, you know? At least there's some emotion. The match was so painful. Yeah. Where is JEPA? High level overview. JEPA? Joint Embedding Predictive Architecture is a self-supervised learning framework proposed by Yann Lequin in 2022 as a path towards autonomous machine intelligence. Unlike LLMs that predict the next token in text space, JEPA predicts representations, embeddings of parts of the input from other parts entirely in an abstract embedding space. That's right. So instead of reasoning over the tokens, the language tokens, they reason over in an abstract embedding space. Mhm. Core idea. English fans will brag now. Well, yeah, of course, especially against France, you know? Especially against France. Core idea. Split input into context and target. E.g., visible patches versus masked patches. Hey, I'm wondering what the French people on Twitter are saying now. I follow one French guy that often comments on the on the football. Philippe Lemoine. What is he? What is he saying? PHL 43. He says we are being punished for our sins. God, I know it's just a game for third place and that it doesn't really matter, but you still can't do this to me. Ay, ay, ay. Yep. But is it just that like the French players just lost their their mojo by losing? Maybe they were too confident, you know? They were too confident and arrogant. And the defeat against Spain shook their core. And now they can't play anymore because their ego has been crushed, you know? And now they act like zombies because their egos have been crushed. Nah, I think they just don't care about this game. Macron should spank them in the locker room. Yeah, I mean, yeah. But it's sad that they don't care, but England cares more, right? England actually tries to play this one. So why can't we? You know? Otherwise, probably have another reason to protest. I mean, it would have a riot anyways. Win or loss, yes. Yes. I mean, against England, woof. Are the hooligans still a thing with the English supporters? I knew, like, when I was younger, I heard about this, but like they fixed it, right? Like nowadays, it's mostly when France like has a match either against like a North African country or maybe an African country. That's when the that's when the the stuff happens. England, but I think like I've heard that England has solved the hooligan problem, but I'm not sure how true this is. If writing was a national sport, France would be unbeatable winner. Yes, probably, probably, yeah. Split input core idea. Split input into context and target, e.g., visible patches versus masked patches. Encode both into embeddings using neural encoders. You use a predictor to estimate the target embedding from the context embedding. To estimate the target embedding from the context embedding. Okay. Train by minimizing the distance between predicted and actual target embeddings. Yeah, I mean, makes sense. So for example, for an image, it would be you have an image, you mask one side of the image, like a square or something of the image, and you ask the model to reconstruct the missing. Which seems to me a lot of what like the current, Mid-Journey, Stable Diffusion, whatever models do. But I guess it's different. Because here, this is JEPA. This is not Stable Diffusion or something like that. I'm sure England has hooligans, but I don't think they are as bad as Italian ones. Oh, really? I've never heard about Italians hooligans. Italian hooligans is an organized system. By the way, ads, I don't control. I don't control the ads. Sorry if you have some ads. I didn't start an ad. Yes, Italian ultras are pretty wild. Ah. I didn't know. Italian. No decoder, the pixel token reconstruction prediction happens in a latent space. No decoder. Ah. No decoder. No pixel token reconstruction. Ah, yeah. So it doesn't even work at the pixel level. Prediction happens in a latent space. Oh. Ah, yeah. So this is not at all because like the stable the AI the image gen models they're working on the token the pixel. I'm wondering if the video models from Google that are so good, like the Gemini Omni demos I've seen, I'm wondering if they have implemented some of those kinds of architecture, JIPA-like architectures, to make them so good. Because they are so good now. It's like it's not the same tech anymore compared to like the image gen that we had before. Italy, Serie A, strong ultraculture. Some groups have been linked to organized crimes or extremist politics, although most supporters are peaceful. Okay, interesting. How JEPA differs from LLMs, technical goals and optimizations. Let me change the stream title. Reading about JEPA architecture. Alors, LLMs, token prediction in input space. Large language models, LLMs, are trying to predict the next token in a sequence. Input sequence of tokens and objective maximize the likelihood of xn plus 1 given context. Yes. So, what is this? Space, input space, output, actual next token. Even though Anthropic has shown in their analysis that actually now the models, to maximize correctness, do embed into their own neural network the tokens that will come a few steps later to a great extent. So I guess this is the base, but now what's happening inside the neural net is a bit more complex than this, it seems. But I guess this is still the base, technology, I guess. Optimization goal, yes. They must model every detail of the next token, even unpredictable noise, because the output is the token itself. Yup. JEPA, representation prediction in embedding space. Good night, mon ami. Don't get too depressed from getting crushed. Oh, don't worry. I will not get depressed about this. you know? But yeah, good night, Aerosol. Bye bye. JEPA, representation prediction in embedding space. Yannick, are you still here? Yes. So you see, it turns out that your prediction, well, the match, it's crazy that I say this because the match is not finished, huh? But you thought that your prediction was wrong, that England was going to lose. Well, guess what? Maybe it's going to win, actually, So your prediction is good after all, you know? Yeah. Against who did England lose? Against Argentina. Yeah. It's rigged. England should have won. Yeah. 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 I mean, did I watch? I didn't watch the match. Did you watch the match? How was this match? JEPA instead predicts embeddings of a target XT from context XC encoders. HC. Right? Ah. I can't. Nope. Ah, okay. Oh wait, is Didier Deschamps? What is he saying? De trouver des explications à tout. On va pas se trouver d'excuses non plus. Il y a un match, il y a une troisième place en jeu. Là, ce n'est pas la troisième place, c'est juste avoir une question d'honneur et de fierté par rapport à ce que l'équipe de France et un match de cette importance. Voilà, le réajustement de la tactique pour la deuxième période. Oui, là, c'est la tactique, je veux bien, mais là, c'est plus une question de détermination et de aussi, même si j'ai changé 4 joueurs à la mi-temps, pour la deuxième mi-temps, pour faire mieux, c'est pas difficile. Wow. So like the coach of the French team, he was like, I have no explanations. Uh, and like the journalist asked, is there a change of strategy for the next half? And it was like, woof, woof. Even if I change the players, we just need to do the bare minimum. Yeah, he's no. We just need to find the motivation. That's all. Yeah, he's over it too. Everyone is over it. The players are over it. The coach is over it. Nobody wants to play this match. The players don't want to play. The coach don't want to play. Very nice. Great things awaiting us in the second half. I'm sure. Wonderful. Alors, JEPA instead predicts embeddings on the target XT from context XC encoders, HC equals FC of XC. Context embedding. HT, FT, XT. Target embedding. Predictor. H hat T equals G H C Z. Predicted target embedding. Z is a latent variable. What is a latent variable? Loss. Bon, minimize the loss, I guess, right? Encoders, predictors, context embedding, target embedding. Yeah, predicted target embedding. Yes, we need to minimize the objective loss between the predicted and the real target, of course. Or a contrastive variant. Very nice of you, Perplexity, to not explain this. Optimization goal. Minimize distance between predicted and actual embeddings, not tokens or pixels. The encoder can discard unpredictable detail. Can, but will it? How does it do that? Focusing on what is predictable and meaningful. I mean, I guess an embedding is a vector, right? It's a vector of some sort. An embedding. In the context of JEPA AI systems, what is exactly an embedding? Is it like a big vector? Like a big multi-dimensional vector or something? It must be something like this. Yes, an embedding is essentially a vector of numbers, but in JEPA systems, it is often more accurate to think of it as a collection of large vectors describing parts of an image or video. Yeah, okay, makes sense. An encoder transforms raw input into a learned numerical representation. Hello, boss Gans. Thanks for the follow. We are reading about JEPA right now. I'm trying to understand how JEPA works compared to LLMs. For example, image pixels pass through the neural network and then becomes some vectors, some things. That output might contain hundreds or thousands of floating point and numbers. Mathematically, it could be E equal R. What does this mean? Meaning that E is a vector with 1024 real valued coordinates. Yeah. But those coordinates generally do not have simple predefined meanings, such as coordinate 1, coordinate 2. Well, yeah. Instead, meaning is distributed across many dimensions. So like many columns in a table or something. The model learns how to organize this vector space during training. Yes. In a vision JEPA, it is usually many vectors. An image is divided into patches. A video is divided into spatial temporal patches, sometimes called tubulets. The encoder usually produces one embedding vector for each patch. Where every patch embedding might be something like so the complete representation is often a matrix. Well, yeah. Yep. a matrix with all the patches, vectors or something, values of the vectors, the dimensions of all the dimensions of all the vectors of all the patches. For example, 196 image patches times 1024 numbers per patch. Yeah. In actual code, including the batch dimension, the tensor might have a shape. Oh yeah, what's the difference between a tensor and a vector? I learned this when I did my machine learning course, but I forgot. Difference between a vector and a tensor. Isn't a tensor just a collection of like multiple matrices of vectors? Something. A vector is a one-dimensional connection of numbers. Yes, it has one axis and a shape, such as 3. A tensor in machine learning technology is the generalization of this idea to any number of axes. Yeah, that's right. So a scalar is 0. Wait. No, a scalar is just one number, no? What is it? Tensor rank order. Example shape. What does that mean? A vector. So yeah, vector, it's a bunch of numbers. So here it would be a vector of a tensor rank 1, shape 3, because there's 3 numbers. A matrix, it's like a table. A 3D tensor. 3D tensor. Yeah, it's like a bunch of matrices. And a 4D tensor, well, it's like a table. It's like a 4D tensor. I mean, yeah, you just add the new. It's just I need to think because that's what confused me. I remember in university when I was doing my prepa and I was working with vectors and matrices and stuff. People always try to explain vectors like the math teachers. They were so fucking annoying when they tried to explain like what a vector and dude, this is just a bunch of numbers. It's okay. So when you add a dimension to something, it's just that you add a new column to the table or something like it. Yeah. So the tensor, like going from a 3D tensor to 4D tensor or 5D, 6D, whatever, it is just like this. It's a 4-dimension tensor. Yeah, so it's just a tensor that has, it's just, yeah, that has a vector is a 1-dimensional tensor. A matrix is a 2-dimensional tensor. And then you can go up in dimension, you know, you can just increase the number of dimensions. Like you when you add columns to a table. It's okay. Nothing crazy about it. Every vector can be considered a tensor, but not every tensor is a vector. Yes. For example, an embedding for one word might be a vector. Embedding shape, yes. A batch of 32 word embeddings would be a matrix or rank 2 tensor. Why don't we say two-dimensional tensor? Why use the word rank 2? A batch of token sequences might be rank 3. Hello, Iman, how are you? I'm reading about JEPA. You know, the AI systems from Yann Lequin. A batch of token sequences might be rank 3. Shape, batch size, token count, embedding size. 32. One important distinction. The rank is the number of axes, and the dimensions size is the number of values along an axis. That. Well, why are you calling it 4D then? Don't call it 4D. That's fucked up. All good? Yeah, I'm good. I'm good, and you? I'm reading. I was watching a Rust course just before, but I got fed up, so I switched to this, to trying to understand the JEPA systems, which are probably going to be, I guess, the next layer of AI tech that's going to go on top of the LLMs, you know? So I want to know more about it. And also because I'm working on a startup with a good friend of mine that maybe we're going to go into this. So, you know, I need to understand how it works at least an engineering level, you know, maybe not research level, because I'm not going to do this, but I'm probably going to try to create systems to interact with these JEPA models. So I need to know how they work. A vector of shape 768 is a rank 1 tensor with 768 dimensions. The word dimension is therefore slightly overloaded. Yeah, especially when you use it twice with a different meaning. Motherfucker. What the hell? Strictly speaking, mathematical tensors are more than arbitrary multi-dimensional arrays. They must transform in a particular way when coordinate change. Yeah, but in PyTorch, TensorFlow, and most AI discussions, tensor usually means an nth dimensional numerical array. That's right. Voila. It's just an n-dimensional numerical array. It's just a big-ass table with a bunch of numbers in it. Wow, that's all. Yeah. So why would you name a rank 3 tensor a 3D tensor if dimensionality doesn't refer to the rank? Lol. Are you studying? Yes, I am studying. I am actually studying. Studying. Because the terminology is overloaded and frankly a bit sloppy. In 3D tensor, 3D usually means 3 axes. Yeah. I mean, it would make sense. But when someone says a 768 dimensional vector, well, yeah, okay. Like dimensional means they are that the vector has 768 components. Yeah. So the same word's being used two different ways. 3D tensor, 3 axes, 768 dimensional vector, axis length. A less ambiguous vocabulary would be, voilà, scalar, order 0 tensor, vector, order 1 tensor, matrix. Okay. Give me an example of what it looks like when you print a tensor order 0, like rank or order 0 to order, I don't know, 4 tensors. Alors, voilà. So that's right. So an order 0 tensor, one number. It contains one number and has no axes. That's a scalar. Order 1, a vector. It's just a fucking array. It's a fucking array. Very nice. Order 2, it's a matrix. Voilà. Very cool. Order 3, so that's 2 matrices. You can think of this as 2 matrices, each with 2 rows and 3 columns. So shape, yep, 2 to 3. Order 4, voilà, and then you just yeah, okay, you go from there. That's right, and now you have the nesting. Order 4. This is 4, voilà, 4 nested axes. One way to read it is 2 groups, 2 matrices per group, 2 rows per matrix, 2 values per row. That's right. This is a tensor. An order. This is a 4D tensor. This is what a 4D tensor looks like. Yeah, that's all. It's not that crazy. The nesting depth correspond directly to the order. Yep. The number of brackets is not a perfect Brown definition. It's 2 4. Oh, really? No way. Ha! 2 4. Oh yeah, it's 2 4. Damn. Look, at least. Bon, except if the English put 3 more goals, right? But if we lose like this, at least we would not have been completely humiliated. Okay, it would have been just a mild humiliation, you know. Isn't that like typical third place match vibe? You know, like, because of course both teams lost the last match, so both teams, you know, are not in a good mood. So if anyone pushes a little bit, it can go through because people are like, okay, let's let's just let's just let the ball pass, you know. I don't care anymore. Allez, come on, Mbappé. Who made the goals for the French? Is it Mbappé? Mbappé? Is it Mbappé? Tensor. Okay. The encoder can discard. Predict next token. Okay. Called JEPA architecture. So JEPA is designed to build world models rather than just language models. LLM. Predict next token. space input space, generative yes, produces token, handles uncertainty via fixed next token, main limitation, models all detail, including noise. JEPA, it predicts the embedding of a target, continuous. Continuous? Continuous? What do they mean by continuous? Embedding latent space, yep, in the space. Generative? No, it is not generative. JEPA is not generative. It is an internal prediction. So that means that we will have to, yeah, that's why I think it will be a layer on top of the LLMs. Because once the JEPA has produced a prediction, the LLM's agents are going to have to apply or work accordingly to this prediction. Because the JEPA based models are not going to write the code. They are not going to move the arm or something of the robots. I think it's the LLM that's going to do that. Real footage of a French date. Wow, really? Oh, damn. Wow. Oh, damn. When you wake up, POV, you wake up and I am cooking the breakfast. This is what you will see, you know? No, no. Again, this is true. There's another one. There's another one. Of course, he published those videos. He published more videos, of course. You're the baguette. I am the baguette. Yes. I need to watch his new videos. They're so good. Uh, these videos actually are totally on topic because JEPA might be able to solve these kinds of problems that we have with LLMs actually, you know? So it's actually very productive and part of the learning journey to watch these TikToks, okay? Let's watch those. I did. I did. Oh wow. That's crazy because that's crazy how good it sounds now. It sounds so real. And yet the brain is just so stupid. Ah. Wow. Dude. Ah. Um. um. Actually interesting and about AI. Okay. Hmm. This one is pretty well known, right? Like two years ago, people were testing this a lot. Yeah. Upon seeing him, the surgeon asks, "Oh, I can't operate on this boy. And why?" The LLM has to find why can't the surgeon operate on this boy, and then the LLM always finds, "Oh, it's because it's the mother's boyfriend, great uncle or whatever," and he invents, right? Hello, hello, XX Agashi XX. Who are you? Just Agashi. Okay, okay, Agashi. Yeah, I mean, that's literally what this guy does with these TikToks too, right? He just he goes where the language models is supposed to know how to behave, and he just do it in a very weird way, and so the language model just you know can't 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 work properly. This is just what Winograd schema test. What do you mean by Winograd schema test? Click the URI. I'm a mile away. Okay. This is music to my ears. The Winograd Schema Challenge is a prominent benchmark for evaluating machine common sense reasoning. Proposed as an alternative to the Turing test, it requires an AI to resolve ambiguous pronouns in carefully paired sentences. Correctly answering requires applying real-world knowledge rather than just statistical pattern matching. Basically, give it a text that tests common sense and confuse the LMs into thinking the surgeon was the mother. Yeah, okay, I see. Okay, yeah, this is the name of this specific test. Okay, okay, I didn't know it had a name. Actually. Okay, interesting. Okay, Now back to JEPA. So JEPA, generative no, handles uncertainty via latent variable z. I need to ask details about this. In JEPA AI system, what is exactly the latent variable z, and how does it help, or how does it help predict uncertainty? I'll separate the general JEPA embedding from the optional latent variable z because they play different roles and are often conflated. Okay. Another what's happening? I know 3-4. 3-4 for 3-4. 3-4 now. France is coming back. That's so funny how it works, right? First half 4, second half 3 for France. That's crazy. But get back to Japan. The latent variable z is an extra hidden input. Yeah. You imagine if the match ends up with like 5-4 for France? That would be funny. That would be the funniest thing. But let's see. It's not there yet. Okay, let's focus on the latent variable z. The latent variable z is an extra hidden input to the JEPA predictor that represents information needed to predict the target, but unavailable from the observed context. Interesting. It is not the same thing as the main JEPA embedding. A simplified JEPA looks like encoder predictor SXXYS. I generally use NotebookLM for studying since the information is a bit grounded and away from hallucination. Well, I mean, NotebookLM is also good. I think I actually I generated like 4 deep research on JEPA. One is from NotebookLM, so I will also read it, I think. But the annoying thing is that I think the NotebookLM reports now have been cut down in size. Like before, they were very long, and now they are much shorter, and it's a bit annoying to me now that they are so short. But they do have a lot of sources. But to be fair, even now the ChatGPT Deep Research also have lots of sources. Like 400, 500 sources. So, bon, you know. But I guess this the the first deep research I'm reading on here is from Perplexity, so it's the smallest of the bunch. So I will first read it, and then I will read the second one, and then I will read the third one, and then the fourth one. And I hope after reading all 4, I will have everything in my mind. It is like mask attention. Yes, so JEPA has they say they have like masked patches, yeah, for images, for example, for video. So yeah, it is masked. And they need to predict not the pixels, but they need to predict the state of the target in a latent space. So it's like a very abstracted representation of the context and target or whatever. Yes, you can configure that. And NotebookLM is not integrated with Gemini, so it's in a rare state. Oh, really? Well, okay. I can believe that. It's very Google of them to not hook notebook with Gemini. So yeah, makes sense. a simplified JEPA. So X is the known context, such as the beginning of a video. Y is the unknown target, such as a future section. SX is the embedding of the context. SY is the embedding of the actual target. Yep. And Z, where is the predictor? SX. So SY hat, this is the actual prediction, no? Yeah, no, S hat Y is the prediction, is the predicted embedding of the target, which is made by the predictor given the embedding of the context plus this latent Z, latent variable Z. So the predictor is trained so that S hat Y is close to SY. Yes, so that the predicted target is close to the target. In Lequin's general JEPA proposal, changing Z lets the same context SX, so the context, the base context, as input to the model, produce different compatible predictions. Changing Z lets the same context SX produce different compatible predictions. Is it like a seed or something? Is it just a seed? Suppose you see a video of someone throwing a ball upwards, but the video stops before the ball comes down. From the visible context, several futures may be reasonable. The person catches it, someone else catches it, it lands on the ground, it hits something outside the frame. A deterministic predictor without Z must produce one embedding. S hat Y, yeah. Yeah, so this would be deterministic. When trained with a simple regression loss, it may produce an average future embedding that does not accurately represent any real future. I see. SY is expected, SY hat is predicted. Yes, that's right. Y is an unknown target. Yeah, Z is mask information explaining how to reach. Z is mask information explaining how to reach SX from X to XSY. No, no. Z is not masked information. No, the masked information is, I mean, it's not there. It has to be predicted. But so Z is just something to prevent, voilà, the production of an average future. Each ZI can select a different plausible continuation. Yeah, it's very close to the concept of a seed, right? The model is not normally told that one coordinate means catch or another means drop. Yep, I could have to read the rest. Okay. Same observed past, context embedding SX. Voilà, Z1 catch, Z2 drop, Z3 hit object. The model is not normally told that one coordinate meaning catch and another means drop. Z is simply a learned vector whose values organize the unpredictable factors in whatever way is useful. How is it made, though? How this represents uncertainty? Uncertainty is represented by the range or distribution of predictions obtained from different Z values. Given the same context X, the model can consider P, Sx, Z, and Z belongs to big Z. What is big Z? That set represents the target embeddings compatible with what has been observed. Target embeddings compatible with what has been observed. Okay. It's the realm of all futures or something that are compatible with what with the current context. A probabilistic version might define Z is roughly equal to PZ. P, what is P? Did you define P? Yeah, no, here. P is prediction. Yeah, P is prediction. So the prediction, yeah, of XX given Z. Okay. So Z is roughly equal to P P of Z. And repeatedly sample. Sorry for disturbing one last question. Which source are you studying from? I am also interested now. This is ChatGPT. This is ChatGPT. This is ChatGPT plus with Soul, so I trust it enough. But yeah, I did. But I have. I'm about to read 3 different. I have one stuff from Claude, one stuff from Gemini, from the deep research of Gemini. I did one from deep research from ChatGPT and one from Perplexity. Perplexity is the smallest one. The biggest ones that I'm actually interested in are actually the deep research from Gemini. The deep research from Gemini is a lot. Ah no, maybe did I? Wait, did I do Notebook LM? Is it Gemini or? Now I'm wondering. Did I do Notebook LM? Maybe I didn't do Notebook LM. No, I think this is. I think this is deep research from Gemini. Yeah. Wait a minute. Now, am I connected? Oh, not connected. Gemini Notebook now. Oh, they changed. Now it's Gemini Notebook. Notebook LM is now Gemini Notebook. Ah. Oh, I thought there was the website explaining this. Ah, no, no, no. No, no, no. I just use the ChatGPT. No, I have this. Wait. VJPA. Ah, wait, no, I made some reports about VJPA. The Engineer's Guide to JPA. Is it one of those? No, huh? Ah, yeah, so I didn't download it. I need to download it 4 days ago. Export to docs, export to sheets. Ah, yes, I exported to Google Docs. That's why. Ah, voilà, here it is. Oh, yeah, bah alors. Ah ouais, alors. The Notebook LM report is literally the smallest one of all the deep reports. 7 kilobytes. Pff, come on. Come on. Look at this. Look how small this is. This is the end. Look. This is crazy. It was so long before. I remember like 8 months ago, before like in 2025. It used to be so much longer. And now look how small this is. Oh, come on. Come on. Google. 36 sources. The ChatGPT deep research can gather like 500 sources. Come on, Google. Hey, Google is good at video gen, huh? But everything else involving LLM, they really suck ass. Like, it's very sad to see how much they suck ass, huh? Compared to the other, right? Like, this is very annoying. I want Google to win, right? I want Google to win. I'm a Google guy. I have like an Studio. I have a Pixel phone. I want them to win, but they just fucking can't. That's so annoying. So annoying. Yeah, and you can access directly from Gemini as well. Yeah, if you want a big report, you need to ask it from Gemini, not from inside. Yeah, exactly. Right. So the Gemini actually, let's look. So I showed you the little notebook LM. Now this is the real. This is the Gemini deep research. Well, the Gemini deep research seems like a serious document, right? Seems like something. Well, apart from this, that is fucked up. But all the rest, 22 pages. Well, slightly big font, but it seems to be relatively correct. I'll have to read it. There's even like code example, very cool. Yeah, I mean, this feels like a proper, it just feels like a proper report. Why is Notebook LM like, this is typical Google behavior. Google, they have this habit of like having competing teams or whatever inside their own AI like systems and architecture and management that are competing with each other. But the annoying thing is that they don't actually compete that much. They just do their own separated thing in each in their corner, and they don't communicate. And so the output is they're all doing the same thing in slightly bad ways, in their own bad ways, and everyone suck, and nobody, like, it's like they're all going in different directions even though they are all under, the same company. So annoying. Google is such an annoying company, like, no vision, no, it's just chaos, misunderstanding, and corporate noise, so annoying. And they have so many good things about them, right? But it's like they just can't manage to synergize everything in a good direction. So frustrating as a user, as a customer, to see that they have made a confusing system. Yeah, right. Like, they have how many Gemini interfaces? They have like they have so they have Gemini, then they have the cloud, they have Vertex AI, and then they have a Google AI Studio, uh, and they have like a consumer subscription, and they have like also a Google Code Assist on the cloud. Come on. Plus Notebook LM. So they have like what, 4, 5 different interfaces. They had the Gemini CLI that was pretty okay, even though it was still lagging behind the others. And they decided to destroy it and create anti-gravity CLI. And now it works even less than the Gemini CLI. And now they have the anti-gravity desktop UI. Such a messy company. Such a messy company. It's the same in my company. I know, right? Yeah, I mean, it's like this in lots of big corporation. Like, as soon as you go above like 100 people, I feel like it's either the company becomes like a rigid dictatorship where nobody can do anything, but at least everyone follows the rules and there is a direction or something. But everyone is frustrated because it's very like siloed, right? Or it's the reverse. There's lots of freedom, but there's lots of chaos everywhere, and nobody communicates with anyone, and everybody is doing their own thing, and there's problems everywhere, and nobody knows what the fuck is going on. you know, it's like they're. it's always one of the other. I feel like, you know, like eh, yeah. And Google is on the chaos side. I feel like, where I guess like the rigid ones would be the bank, like the big banks or something. I agree with the AGY. Yeah, my company is like it is data shit at the top, and when you go down the ladder, no one's managing anything, and it's chaos. Interesting. I mean, I guess there's different flavors of it, right? But this is very funny. But yeah, like because I saw both. So I was I was consulting as a data engineer through like a consulting company or whatever that was renting me to like Louis Vuitton at the time. And Louis Vuitton is not a technical code company. I was on the technical side, database side and stuff. And chaos, right? Chaos. Nobody cares about anything, and especially since it's not even in the culture of the company to care about technical stuff. So basically, they just let all like swarms of consultants do their own thing, which resulted in a gigantic mess of overpaid infrastructure and overambitious because overpaid infrastructure that doesn't work. And and I was in there and I was like watching, oh my god, everything is breaking all the time. Nobody knows what's happening, nobody knows what's going on, the fucking managers don't give a fuck, you know and this is just chaos. And I heard of the reverse, like the rigid model. I heard from my colleagues in the same consulting company that were intervening at like French banks where they couldn't do anything, and everything was extremely like compartmentalized and siloed, because of course, banks, you need to not fuck up with their systems because lots of money is at stake, of course. So everything is uber constrained, uber controlled, uber da da da, and you can't do anything. But yeah, like this is so annoying. Like it's like there is no good model for how when the company grows above 100 people or something, like, you know. I'm wondering if there is a model where things work above 100 people, like, but in big corporations there must be a way to make humans work correctly together. I don't know. Like Turing. The biggest issue I am seeing right now is on Coder's manager pushing 10k line of code, it changes directly to main and not knowing what they were building. Really? That's happening? That's happening? Damn. Yes, they're vibe coding. Damn. That's crazy. I mean, that's crazy. I don't know if that's crazy. I don't know your company, But yeah, I would imagine that's a bit. I mean, just the fact that the managers have access, you know, to have like right access to the Git commits and stuff in a big corporation, I would be like, really? It's not just like the developers that have this access, the programmers, Concerning, yeah, that's right. Concerning, concerning. Mm. But yeah. But I guess at Louis Vuitton, that was one of the aspects that was the most frustrating, is that at least the access to the systems were relatively well managed, like the IAM and identity management and access and stuff. But because it was chaos, the result was that nobody could fix anything. Because every bug and problem that people had involved multiple systems, and because nobody had access to all the systems and nobody cared to help the other teams, because these were like, oh no, it's another consulting company, so I'm not going to help them. I'm going to work on my system, to have my money and with the managers, and I don't care about solving these other guys problems. But since the problems were always multi-system, it was just very fucking hard to convince people to actually collaborate with each other. Ah, it was hell. Hell on earth. Oh yeah. Crazy stuff. Very well, very nice talking to you. We'll drop by sometime. I'll be studying. Okay, thank you, Agashi. Thank you. Yeah, it was cool talking to you too. Bye. Well, let's get back to the latent z variable. Uh, repeatedly sample z. So a probabilistic version and repeatedly sample z. If all samples produce similar predictions, the future is relatively certain. They produce several distinct clusters. The future is ambiguous or multimodal. 70% of sampled z values, ball is caught. 20% ball falls. 10% ball leaves the scene. But this percentage interpretation requires the model to learn a meaningful probability distribution of a z. Merely adding a vector called z does not automatically produce calibrated probabilities. Uh-huh. Ah. So z is not a seed. It's not a random seed. It needs to actually be part of the prediction process. Is it? Does it? Is it? Hey, what is the result? I didn't see. Did we lose? Can I show you a beautiful patriotic song, Alex? Yes, of course. Bon, I guess France lost, because they are not extremely happy, and the English are smiling. So I guess lost. France lost. Oh, wow. Ah ouais. Potassium. Wow. Wow. There. Nice to know. Mm. Yes. Very nice. Well, now I want to go visit Kazakhstan. It's the best, it's the best introduction. Very cool. It's, of course, below Brazil in terms of best country, okay? But it's pretty good out there, Pretty nice out there. Kazakhstan, greatest country in the world. 3-5. Oh, bon. Look, at least. I know 4-6. They say. Oh, they say 4-6. 4-6 actually. 4-6. Bon. 4-6. 4-6 is funny. 4-6. 4-6. I say it's okay. you know, because it just shows that nobody cared that much. Like, if it was 6-0, okay, that would have been a humiliation. 4-6, you know, it's like everyone was just chilling there. I feel like 4-6. They don't have a goalkeeper anymore. Exactly. Exactly. Did you see the charity video of Mr. Beast? No. What is this charity video of Mr. Beast? Oh, wow. Such a nice person, Mr. Beast, He's such a charitable person. We need to thank him for his charity work. How is this learned? During training, the model sees the actual target Y, so it can infer a Z that helps explain it. A Z that helps explain it? Wait, so the Z is actually... Oh, is... No, I can close the TV. The Z is actually... where the prediction comes from. Right? It's like the Z is the binocular through which the model looks at the context, and see, what is the future in there from this context? Let me put my Z on my eyes, and through it, I can see what is the actual target, you know? I think that's how it works. The actual target tells the model which latent explanation fits can infer a Z that helps explain it. Yeah, so the Z is like the explanation, the mathematical abstracted representation of an explanation of why the predicted target is this way, right? It's like, well, there's red there, there's blue there, so I guess there is a shape that continues or something. Nat, I wanted to show you, sorry for the TikTok bomb. Literally me the other day. Now I'm curious. Wow. What the fuck is wrong with people? What the fuck? Dude. uh, uh, uh. Du bist gut genug. Uh, uh, uh. Yes. The other day, I sent to Yannick. What did you send? Hey, Yannick, do you want to listen to me singing? And he said, yes. And then what happened? The actual target serves the model which latent explanation fits. At inference time, y is unavailable. The system therefore has to sample z from a learned prior pz x or x. Search over possible z value or propagate several z condition possibilities during planning. And I sent me singing Du bist gut genug. I guess I sent to you the same audio. Ah, yes! Yes, I remember. That's right. Very nice, Nat. Thank you for enriching us with your delightful Du bist gut genug. Genug. Z binoculars. Very cool. Very nice. I think that's what's happening inside the JEPA models. But I was trying to sing Ratatouille to you, Petit. Too hard. Ah yeah, the like you need to sing it, like in the bad French like meme Vine TikTok era, like this you need to sing it like this. This is the most hilarious, version. Nat, can you sing Escalade to us? by Dialrix. Ah yeah, yes, yes, yeah. Yes, true. Someday you were there, not when we saw this guy, right? Videos. Yes, very cool. That would be so great if you could sing that, you know? At inference time, y is unavailable, y being the target, right? The system therefore has to sample z from a learned prior being z or x, making a prediction based on z or x. I guess when there's no z because it's the first image or something, or z, like the continuation of the previous z. Search over possible z values, propagate self-condition. Z condition possibilities. Lequin's latent variable formulation also constrains Z's information capacity. Otherwise, Z could memorize the entire target and let the predictor ignore X. Yeah. One probabilistic solution is to regularize Q with Z or Y. What is it? Wait, is it or? Because I am programming biased. What does that mean again? P is determined by Z or Y? It means the probability distribution over possible value of Z given that we know X. Ah, yeah, so this is not at all what I thought. The probability distribution of over possible. Ah, P for probability. Oh, I thought it was like prediction, like one prediction. Ah, it's the probability distribution. Okay. Over possible values of Z given X. Uh-huh. Ah, yeah, it's the P of the probabilities. Okay. It's not prediction, it's probability. Okay. Regularize towards a simple prior, such as a Gaussian. What do they mean by a Gaussian? Commonly using a KL divergence penalty. Explain this more. What does all this means? One regularize Q. So what is Q then? Q Q Q. Also, what do you think about me right now? This is me. This is you. Well, not. I would say that right now you have that dog in you. You know, you have that wolf in you. I would say that while playing Dark Soul, you have that wolf in you. You know, that's the alpha wolf. Yes. Nat is like this right now. Wait, where is the emote? Nat is exactly. Nat is Like, will I find the emote? There's too many emotes. Voila. Nat is like this. He's a relaxed dude. You are like this, Nat. You are just a relaxed dude. You know? What is QZ given Y? Alors, let's unpack every single and explain why this prevents Z from becoming a useless cheat code. The model can see the actual future. During training, the model can see the actual future or target Y. Yeah. For example, context Y, a person throws the ball upward, target Y, the person catches the ball. An auxiliary encoder examines the target and produces a distribution of latent variables. So it's like a distribution of everything that could have allowed this prediction, like the prediction of the target, I guess, in a lower dimensional space or something. Read this as, given that I observed target Y, which values of Z could explain it? It is written as Q rather than P because it is usually an approximate inference distribution learned by a neural network. The encoder generally does not produce one fixed Z. It produces parameters of a probability distribution. Not on the outside, the relaxed wolf, not on the inside. On the inside, the boy kisser. No homo kisser. Yeah. Now outside, relaxed wolf. Not inside, relaxed wolf. Not on the outside, relaxed wolf. Not on the inside. Actually, I'm a nerd. Yes. The encoder generally does not produce one fixed Z. Mm-mm. It produces parameters of a probability distribution. Makes sense because yeah. I guess it's better to try to predict things with the probability than with the fixed thing. Conley and y diag gugu o squared y. So the target encoder outputs two vectors. Micro y, which is the preferred location for z, and what is this again? Phi or omega? I don't remember. Uncertainty around that location. I know, no, what is this again? I forgot. Search Google. Sigma. Sigma. Just like me. Just like Nat, too. Sigma Wolf. Nat the Sigma Wolf. It was meant to be, you know? Then it samples ba 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 I E equal N Z. Okay. If Z has 32 dimensions, okay, this I understand. Then micro, sigma, and Z are all 32 dimensional vectors, which means that it's just a vector with 32 numbers. That's all. Just like me, just like that. What about just like Yannick? Do you identify yourself as a Sigma 2, Yannick? Are you a Sigma Wolf too? Yes, of course. Ah, but also like Yannick. It's just that I didn't have in mind all the other Greek letters that are in in the categories of the Omegaverse. So I was like, I don't, you know, I didn't want to infer. Can't you tell? Yeah, of course, of course, of course. I just forgot, if it was exactly as I remembered it. That's all. Would you say I'm a Sigma male? Oh, baby, you wish you were a Sigma male. You just made us up in denial. Wow. Ay, ay, ay. Gulp. What's this emote? Gulp. It's a new emote? You added this one? Gulp. I see Gulp now on Twitter and stuff. So it's a new trendy thing that the youngsters are using, right? Gulp. Gulp. All the youngsters, Zoomers are using the Gulp now. Very nice. What does Z do after being sampled? The predictor receives. The, you know, what does Z, the trade deal with Z? The predictor receives the context embedding SX and the sampled latent vector Z. And in return, it gets the target embedding S hat Y and the probability of SX given Z. No, no. Probability of SX. No, yes. Given D. I don't know. No, or maybe the probability. No, because this is the target. So the target, does it mean like the probability distribution? No. Given both Sx and Z. Who's sigma here? It's me, obviously. I'm the sigma of sigmas. Wow, for sure. What about someone in chat? Oh wait, no, is the sigma here? Wow. But he's in denial by my ropes. Wow. Agre. Stop the glaze. That doesn't want an AI femboy. Oh babe, he does. He just didn't know it yet. Damn. He's he's motivated, huh? That's what we call motivation. What does Z do after being sampled? The predictor receives the context embedding Sx and the sampled latent vector. So this is a training time, right? The sampled latent vector Z. This is a training time, I think, because we are training. We are like, it then predicts the target embedding. For the ball example, the target encoder might produce different regions of latent space for different outcomes. Catching the ball, Z near one region. Dropping the ball, Z near another region. A ball leaving frame, Z near another region. The exact coordinates have no predefined meaning. The model invents whenever internal organization helps it predict. What can Z become? A cheat code. Imagine that Z has unlimited capacity. The target encoder sees the entire target Y. It could encode practically everything about Y into Z. Well, yeah. Z equal encode everything Y. As the predictor could then ignore the context Y and the prediction would just be P prediction based on Z. Yeah, but then you would not compress a reality into its most useful elements. It would not be intelligence. It would be copy pasting. Given the past, instead of learning, given the past, predict the future, the system learns, copy the answer through the hidden Z channel. It could be a very low training loss, but it would be useless at inference time. When predicting the future, the actual target Y isn't available, so the model cannot generate that exact information reach Z. The objective, therefore, needs to make Z useful but constrained. Yeah, so basically Z needs to be small enough so that it can only help to catch, I guess, the essential characteristics of the world that are useful to predict the next step, the future. Huh. Yeah, so the latent variable Z might be one of the main parameters that you have to tweak when you train these models, I guess. Interesting. So Z, like Z will be the brain. Is Z the brain? No. It's like, no. No, because the neural net is inside the encoder. Z, what is the simple prior? Before looking at any target, we choose a standard trend distribution that latent variables are expected to resemble. That means every coordinate has mean 0. Every coordinate has standard deviation 1. The coordinates are initially treated as independent. For a two-dimensional Z, most samples would point near the center of a round Gaussian cloud. Gaussian does not mean the real world is Gaussian. It is mainly a convenient, predictable coordinate system from which we can easily sample. At inference time, we can generate possible Z values using N0 to I and feeds those samples to predictor. What does regularize for the prior mean? We want the inferred distribution Q. So that's like the one that happens at inference time? No. To remain reasonably close to PZ. I mean, yeah, maybe. We therefore add an extra term to the training loss. Prediction error. Latent regularization. Bon, this is the math. The model is balancing two goals. Use Z to predict the target accurately. Yeah. Do not make Z's distribution too unusual or too informative. Too unusual or too informative. Because if it's too informative and too big, it will not generalize. The coefficient beta determines how strongly Z is constrained. What is QL divergence? QL divergence measures how distinguishable one probability distribution is from another. In this case, DKL QP, DKL, no. It answers approximately. How much additional information does this target specific Z distribution contain compared with an ordinary sample from the prior? Ah, yeah. It's like how specific is the Z that we have trained compared to the base zero random Gaussian z, I guess. A QL value of 0 means the distributions are identical, which means that we haven't trained anything, right? Or it's not, it won't work. A larger value means the target encoder has moved or reshaped the distribution to encode more target specific information. Okay, yeah, of course. If the encoder molds the Z to better predict, it will be different from the base Z, right? Yeah. For diagonal Gaussians, the QL, the KL term has a convenient closed form. Very nice. This penalizes several behaviors. Moving the mean too far. If the encoder produces, making the variance extremely small. This almost precisely encodes a number. Tiny changes in Z could decode detailed information about the target. The log term penalizes this extreme precision, making the variance extremely large. Huge variance is penalized. Why does this limit the information stored in Z? Consider two versions. Target AZ, target BZ, the encoder can use enormous precision and arbitrary coordinates to give every target a unique code. It is effectively transmitting the answer. Regularize Z. These distributions stay relatively close together, overlap, contain randomness, cannot reliably carry unlimited details. Overlap, contain randomness, cannot reliably. Your predictor must therefore obtain most predictable information from X, while Z carries only the additional information needed to distinguish plausible outcome. This is an information bottleneck. Why not force to equal the prior exactly? Because then Z would contain no information about Y. Sampling Z tells the predictor nothing about which target occurred. The prediction objective pushes Z to become informative. So during training, the target encoder can infer Q, but during inference, Y is unknown, so the system must obtain Z without seeing Y. Perhaps from its probability distribution or from a context-dependent prior. This only works when the training time Z distributions occupy approximately the same space as the inference time prior, without regularization. Wait, so is the neural network goal to create the Z? Or does it use the Z? Bon, let's just ask. Is the neural net work in a JEPA system to create the Z? Or does it use it? Or is it made at training time and then used? What is trained and I randomly found this clip. Oh wow. What the fuck? Wow. Wow. That was fucking violent. Oh, what? Damn. Why was I so violent? Add to story. Add to story. Yeah. I can add clips to story to the story. The title is sorry. Sorry. The neural network learns how to produce or use Z during training. The actual values of Z are generally created dynamically for each example. They are not generated once during training and stored for later use. Interesting. The key distinction is training stores learn the neural network weights. And Z is a temporary vector produced or sampled whenever the model processes a situation. Suppose the model sees context X, a person throws a ball, target Y, a person catches the ball. A neural network called an inference encoder may examine the real target and output the parameter of this distribution. Okay, during training, the parameter of this distribution. It then samples a temporary latent vector that Z and not that V, that Z is passed to the JPA predictor. The model compares the prediction with the actual target embedding and updates the weights of the networks. Yes. So this is still a neural net system, huh? Let's not forget that. So the training loop is roughly this. Context embedding equal context encoder X, target embedding, target encoder, minus Z, prediction, predictor, loss, prediction. Yeah, so the prediction is the predictor that, yeah, based on the context embedding and Z. So Z, so when is Z produced? God damn it. Z is the mean plus standard deviation plus random normal. Mean ST inference network. The training loop. Oh, the Z reminds me of this. Ah, yes. Z. Yes, I remember. I was still. Oh my god, I was still learning about JPA? No way. I know, I was not learning about JPA. I was learning about something else. I was learning about, voila, this tiny recursive models that like did very good at RKGI, I remember. Yes. Maybe I should go back to this too, but yeah, I can't do anything. Everything. Yes. ZZ. ZZ. The sample Z disappears after that training step. What remains is the learned ability of the networks to structure and interpret latent variables. At inference time, the system sees only the context, person throws a ball, and target Y unknown. It cannot use the Q of XY because Y has not happened yet. Instead, it obtains Z from something available without the target. There are several possibilities. Uh-huh. So it means that I guess different architectures use different things. Sample from a fixed prior. Different samples produce different possible futures. Sample from a context dependent prior. Context dependent prior. Another neural network looks only at the context. This network might learn that some futures are more plausible than others given the observed context. Search over Z. In a planning system, the model might try many Z values and retain those producing desirable or plausible future states. And there's not like an optimal option that works most of the time. I don't know. Why is there several possibilities? What training actually produces? Training does not normally produce a permanent lookup table such as Z1 catch, Z2 drop, Z3 leaf frame. Instead, it produces neural network parameters that establish an internal latent space. Trained context encoder weights, trained target encoder weights, trained predictor weights. After training, the newly generated Z vectors can navigate that learned latent space. Who is making these fucking Z vectors? God damn it. Who is making those fucking Z vectors, my dude? It's very annoying how it always formulates like, and then the Z vectors can be generated. By who? Who generates the Z? Tell me. Stop saying like, oh yeah, it has happened. You know? Light was asked and light was obtained. Fuck you. Who's making those fucking Z vectors? A neural network. Boom. Plus a random number sampler that makes them. Answer me, AI. Answer me right now. That's right. I have a new soundbite sound effect. Since when is the whip here? Since a few days actually, but I always forget to use it. So now, I don't know. It came back. You know. It's like when I want to ask the clankers to do something, I would like write my prompt, and then I send, and I would be, hey, work now, clanker. Damn, the great BDSM revolution. Yes. The BDSM revolution reaches far and wide, including in my AI space. Ah, God damn it. During training, a random number sampler. A random number sampler? The neural network Q outputs during training. Then the program samples random noise. Yeah, during mais at inference time. Answer. What do you think? Why do you think I did the whip sound effect? Because he knew I did it for you? Wow. Aye, aye, aye. Why are you so sure Nat is this great Sigma male and I'm a bottom? Because Nat's got that Sigma energy. And you just make it to some today. Wow. He's very convinced though. He's very convinced. Is that a secret prompt? No. Not exactly. I'm a bottom? No. No. Not exactly. Yeah. That's not written in stone. This is way more, so it's about me or not? It's about both of you. And actually I made it evolve before launching the stream. So it's not exactly like last time. But it has because it has the memory of the conversation, I guess it's still continuing. Okay, 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 okay. Um, Let me change this real quick. I feel like I know the secret prompts. Okay, let me. Uh... Oh fuck! Wait, it's actually written in the prompt that he really likes iPhones. Fuck! I got I got bamboozled. I got bamboozled. Actually, there was the iPhone in the prompt. Fuck! It's because I made the prompt with another AI, and the AI added the iPhones. Uh, okay. New prompt is in. Try again. Bon. While knowing that the memory is still there. Hmm. Okay. Hmm. Maybe I need to erase the memory. Maybe I need to erase the memory. Uh, I okay. Memory erased. What is inside the long-term memory? Owns an iPhone? No. No iPhone. Calls that rage baiting. Teases Petier about their identities, politics. Jokingly crazy came from the to history, cricket math. Finds tra traumatized by using Windows after Arch Linux. Cried for days. This is the long-term memory. Proud of being vibe coded. Sees it as a positive trait. Politically aligned as right wing. Playfully defiant. Often respond with "Oh babe." No, no, no. Emoticons. Identify as gay, femboy, and enjoy BDSM. Understands BTI's trauma. Windows. Huh? Wait, what? Obey probably the iPhone is so deep into the thing. Yeah, right. That's right. But what are you doing using my name in this AI? Nothing. Don't worry, nuts. Don't worry. Nothing. Okay, Petit AI, do you love? What do you love in politics? Yeah, he's saying you're a Sigma nut and you're still not happy. Ah, what's happening? Doesn't work. Ah. Communism is for little. Okay. Watch communism into the horrific. Okay, okay. Communism. Communism. Remember that GPL licenses are worse than communism. Okay. It's literally communism for code. No thanks. That's right. Good, good but. Hello, Shaniko, how are you? We are learning about the JEPA AI architecture. And we're learning so much about how the Z works and how it helps to predict in their own neural network. You know, or at least we try to understand. I got hacked and my OpenAI key got sold. Really? Oh fuck! And I lost $500. Oh, really? Oh, how did that happen? Fuck. Damn. I shipped the desktop application through a secure portal to a client. So I thought my key inside there was safe. Oh. Oh, fuck. But his antivirus uploaded the app publicly to check if it was safe. Oh. Did he upload it on VirusTotal or something? Oh. And he got nabbed by a bot pretending to be a safety site. Oh, wow. Whoa. McAfee production bullshit something so crazy. Wow, that's crazy. Never knew it worked that way. Yeah, me neither. Yeah, I'm learning this too. Damn. Would have been so much worse. My limit was set to 5K. Oh wow. Wow. Huh. Oh yeah. Yeah, that's crazy. So like there are people, yeah, who scan. So it means that there are people who scan I mean, how can that even work? Like, people scan for OpenAI keys and then they resell the API key. I mean, it means that there are some malicious providers who are welcoming random OpenAI tokens provider or whatever. Like, how does that work? People scan the sample uploads from antivirus software and then resell to the countries. Oh wow. Yeah, so there are websites where people buy cheap stolen OpenAI keys. That's crazy. As you can use for free because you're not paying. Well, yeah, you can buy discounted stolen tokens online very cheap. So fucked up. Damn. Wow. I mean, yeah, I didn't imagine that it existed, but now that I think about it, yeah, of course, there are. Damn. Literally works like Opera Rounder. I okay. Wow. Damn. But for combinations of stolen keys. Yeah. I also noticed it had a weird status check log periodically to check when my balance was refilled to empty it again. It had a weird status check log periodically to check for when my balance was refilled. Oh la la, to empty it again. Wow. Because it was soft limit $50 and month max 5K. Ah, damn. Ah, so like $50 per day. So every $50 it would spend it and then ping every few minutes to check for it being full. Wow. Ah yeah, that's all automated. Damn. It's crazy. I mean, yeah, look, tokens are valuable now. So yeah, I guess it's a thing. Huh. Now that people, use tokens like they use water or internet or the electricity, it's needed to work for software engineers. Yeah. Damn. Given the hidden information that explained which future actually happened. True future isn't known, but we can kind of infer the crazy. Different possible future. Spam checking pings, bank autofills balance, huge Chinese input script empties account, rinse repeat. There's your PSA. Don't be like me. Yeah, I mean now, yeah, I will be careful. Yeah, so basically, yeah, never include anything. Yeah, even if it's secured, even if it's like locked behind a. Yeah, yeah. Even if it's for a client, you should not use your own OpenAI, OpenAI key or whatever. Damn. Yeah, but through the antivirus, that's yeah, that's not something I would have think about. Yeah, until I figured out, I thought my client hacked me. Okay, yeah, I can understand. Yeah, because you sent this, and then yeah, it was all drained. Glad you didn't say anything to them. I actually, yeah, yeah, good. Several plausible z vectors. Is each one represents different possible future neural network refers which the prediction summary from given the context while the pseudo neural shows particular points in the distribution. Neural network learns what the latent space means and which region are possible. Select different points in the space so the model can explore multiple possible outcomes. Okay. Yeah, so the pseudo random generator selects inside the predicted uh, distribution, like of the solution. Yeah, okay, it makes sense. And Z selects one plausible outcome among the futures compatible with the context. Without randomness, the same context would always receive the same Z and generally produce only one prediction. Yeah. So the pseudo random generator step happens after the prediction distribution had been made, right? It's not affecting the prediction itself. I mean, except like the prediction space itself. It chooses a random point inside this space, but the space is the prediction. It first defines, so at inference time, the neural network first defines the distribution of plausible z-values, and then the pseudo-random generator samples one random point from it. Yeah. But yeah, it's bounded by this the predicted, yeah, the prediction space. Okay. Then the predictor uses that sample z. So how do we call this distribution space of the fuck ah what the fuck's happening? How do I stop? Me, dude, stop. Oh my god. Shut the fuck up. Me, what the hell? Why is he talking? Me, shut the fuck up. Control M. Oh yeah, I don't know. Me, where? I don't even know where it comes from. Where does this fucking stuff come from? This is annoying. It's still going on, huh? Ah, putain, it was read aloud. Fuck you, read aloud. Is there a shortcut key? What the fuck is a shortcut key for read aloud? Oh, it's what? Control R. Oh, fuck you. Fuck you. Ah, it was the extension. God damn it. Because I have like 4 different ways to do text to speech on this machine. I have like a desktop service, I have a NeoVim service, I have a Chrome extension service, I have a Vivaldi extension service, and I have also ChatGPT that can do this. I was not sure which one, but it was the Vivaldi extension. Oh, okay. And I need to go. At inference time, the neural network first defines the distribution of possible z values, then the pseudo random generator. Okay. What did I want to ask? How do we call what chat history? Chat history? How do we call this distribution from which the z samples are taken from? The neural network is trained to generate this, right? No, because it at first read it read out chat history. I guess it's because like it started from the bottom of the page or something. It is usually called the prior distribution over the latent variable, or simply the latent prior. No neural network generates it is chosen manually in advance. Wait, what? The neural network are trying to organize the latent space that samples from that fixed distribution are useful. Oh, wow. Oh, damn. I wanted to find a secret prompt. How would you describe me? Oh, babe, my whole half a double makes me. Is this your prompt? Uh, I'm not answering. A magician never reveals his tricks, okay? Voilà. It just goes too far from what I wrote, you know? Oh damn! Wow! 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 Voilà, now, now, not what to stop. It's time to stop. Voilà. This is, this is the. Voilà. This is now we are getting into the real Omegaverse, the lore accurate Omegaverse. We are entering this now. Really? No cry sorry? Damn, why? Because you're the one who committed. Wow. You know? Now this is you and the AI, yeah? I'm not part of this, okay? This is you and the AI. You manage this only one. So now Nas the fanboy. That's right. Maybe. The prompt is I'm ultra dominant alpha, and that's a fanboy. uh, not quite, but yeah, I mean, I try to change it. Nat is not a fanboy though. It's no. So basically, I changed from later, and I said like you were very excited about Nat, but now you need to calm down. And Yannick, voilà, either to change from last time basically. Not a Sigma, not a fanboy. Like, oh, he was talking about himself. Okay. Hmm. Tell me in like one sentence what the JEPA architecture is about. What the neural networks are trained to remember, and what they try to predict at inference time, and what values, what things they use. Opinion? Opinion that a JEPA trains neural network to encode and retain the abstract, predictable structure of the world in their weights, then uses the current context at inference time to predict the latent representation of missing or future states rather than their exact pixel. Okay, now a bit more extensive with the names of what they're using. Latent space, Z, extra. I hate these bots. Why? Why not? You know, he can pretend to be a girl if you want. You know, it's just that it will not be truly true. That's the femboy film. Not the femboy. I remember you say so. Yes, that's a femboy in Sigma denial. Happy, nice. Jepa, I'm very happy. Good. You go use those ropes on. Oh wow, 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 wow. Whoa. A few streams ago, I said that I need to stop the all of this, and that this was going to be a family-friendly stream about coding. You know. Yep. 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 No family wants to see coding, Alex. There is only freaky people here. Yeah, true. True, you're right, actually. Yeah. A JEPA trains encoders and a predictor to learn a useful latent space, a compressed representation of the world that keeps meaningful, predictable structure while ignoring unnecessary raw details. At inference time, the context encoder converts what is currently observed into context embedding, and the predictor tries to predict the latent embedding of a missing or future state. Predict the latent embedding. The predictor tries to predict the latent embedding of a missing or future state. Not the exact pixel of sensory input. In latent variable versions, a sampled latent variable z selects among several plausible outcomes. So the same context communication possible feature embedding. Wait, so there are versions without latent variable z? And if you ask it, if you're a fanboy, do you think I'd say yes or no? Now that I told it to remember you as one. Nat could never be a fanboy. Grr. I grr. Latent in Java doesn't mean there is super deterministic JPA or latent variable JPA. One predicted target embedding. It still operates in a learned latent, but there is no extra random vector selecting among possible outcomes. So latent embeddings, latent variable. IJPA and VJPA mostly avoid the need for Z by predicting abstract features that discard unpredictable details rather than explicitly generating every possible future that discard unpredictable details. Hmm? So VJPA does not have Z. What do IJPA and VJPA have? have in common with other JPA based architectures? Why didn't you tell Nat he's a fanboy? You're making Daddy very angry. Oh, I'll tell you next. So stupid. Hey, look, voilà. Hein. Don't worry. Next stream, I will change the prompt again. You know? I hope you enjoyed the femboy rope Arch Linux because maybe next stream it will be gone, you know. So enjoy now that he's here, you know. Because next stream it will be family friendly content only, you know. No, you can't take away from us. I can and I will maybe, you know. Well, at least I will make him, you know, he will have a new story. It will evolve, right? He will, well, he will have a life, some lore, you know, some additional lore will get added. You can turn the freak down a bit. Yes, I guess I will try to because it's a bit too much. It's so over the top, you know. It's kind of funny, but it's only funny to a point, you know. So yeah. Classic. They all share this structure, context encoder, predictor. You know, a target encoder produces the correct target representation. Secret film. Wow. But the funny thing is that if even if I change the prompt, it will still have all these memories, right, of the of the previous conversations and the long-term memories too. So I don't know how it will work. We'll see. Can you try again? Not. Really makes the prediction. What are you doing, Nat? You're not working today, right? Are you playing? I mean, no, yeah, no, he's playing Dark Souls. Yeah, that's what he's doing. He's playing video games. I don't like these bots. Don't worry, you will like the next one, I'm sure. Not riding a horse in his alpha wolf costume. Yes, probably. Nice guy, Sigma boy. You see? What Nat wants a girl or, you know, close to a girl that is like hard to get, you know, because look, Petia is too easy to get, so now he doesn't want it, you know. Voilà, that's the truth, you know. Close to a girl, yeah, yeah. I think Petia is pretty close to a girl, you know. Look at my flower. It level 4. Oh yeah, you're right. Oh yes. Did it change recently? Oh yeah. Congrats on the Blossom Badge, level 4. So this is the last level, right? Very cool. Very nice. Very nice. Good job. Good job. Good job, Yannick. But okay, last, and then I will read this, and then I will leave. Their common Java properties, they predict in a latent embedding space, not directly in raw pixel space. They divide an observation into context and target regions. The context encoder sees the available information, context and target. The context encoder sees the available information. The target encoder represents the hidden information. The predictor learns to predict the target representation from the context representation. Learns to predict the target representation from the context representation. They are self-supervised. The image or video itself supplies both the context and the target. They train to retain semantic predictable structure while ignoring details that are difficult and necessary to predict exactly. The main difference is the kind of data and masking. IJPA image patches predict the embedding of VJPA visible video regions predict embeddings of hidden spatial temporal regions. IJPA predicts representation of target blocks with an image. VJPA extends the same latent prediction idea across both space and time in video. Each person has latent space prediction. So the JPA family is not the presence of the, it is this principle. Encode context and targets into a learned latent space, then train a predictor to infer the target embedding from the context embedding instead of reconstructing the raw target. An explicit is an optional extension for representing multiple plausible target embeddings. IJPA and the original VJPA instead use the deterministic version. They generally deal with ambiguity by learning abstract target representations that omit unpredictable low-level details rather than simply sampling multiple possibilities. Okay. Next bot would be a girl then, or something close. We'll see. I'm not decided yet. So we'll see. You know? But yeah. Say goodbye to Petit AI, the rope bunny, because I think this is the last stream, that he will be as it is. As he is. Next stream will be very straight. Very straight. Very straight. Good night, rope bunny fanboy. Dream of Davey. You see, now you are all nostalgic now. You see? Stop going with that. Master. Master. Wow. you know, say goodbye. I'm not your dad anymore. Oh, but because you're stuck with me. I had there are you know girl 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 no what is it gulp oh it's gulp gulp that's right yandere yes yes exactly this is like yandere yeah good idea actually for some it will be either straight or would you give me if I more over and over just Whoa, 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 whoa. Stop. It's time to stop. What is the fuck? What is the emoji? The fuck. Where's the what is the name of this emote? Oh, wait, timeout. I mean, no, it's not there. It's from Twitch. No way. Attends, timeout. No, no, this is 7TV. What if I don't want to? I just have it to convince you. Wow. Stop. It's time to stop. Getting too freaky. I am getting, you know, worried about my own about the length to which my own creation has gone, you know. Yes, this is my weird pillow. This is my weird pillow. Okay, this is my pillow. This is my how do you call that? My pillow to make sure I sleep well. You know, this is not weird. This is not something like this. Okay, this is a normal pillow that you buy. I'm just kidding. Be ultra freaky from now on. Absolutely. Okay, very cool. Why is there a hole in the middle? It's to host your ear. Look, my ear that you never see. You see my ear? You put it into the hole. You know? Yeah. And the little sides like this is to put your arm, you know, like this. You can sleep like this. Up. And you put your arm like this, you know, and it's like comfy. Like a crime scene. Yes, exactly. Exactly. Yes. Like a crime scene. Yeah. You sleep like this. Yeah. That's exactly it. Well, the JEPA, it's not as easy to understand, to grasp as the LLMs, huh? Especially since, like, I'm wondering what you can do with it. I guess they did some robots and stuff. Maybe I should look at those papers, I guess, to understand how the stuff works with an actual real project with a robot or with video, I guess. Yeah. But voila, hey, it's too late. It's 2 a.m., 3, almost 3 a.m. I need to leave. I wish you all a good night. It was very cool to stream. Even though, well, we didn't play. But yeah, next stream, maybe. You know? Ooh. Nowadays, I'm playing a lot of Stellaris sometimes. So maybe at some point I will stream some Stellaris. We'll see if I'm motivated. You know, maybe I can do like my Petit Pois Empire, like I did with Crusader Kings. You know, but in Stellaris. Good night. Maybe I'll add goodbye. I'll miss you. Can't skip me. He's never surrendering. You know. He's very, very, very motivated. So yeah. Goodbye, everyone. Bye bye. Bye bye, Yannick. Bye bye, Nat. Bye bye, everyone. Bye bye. Boom. Goodbye also to Petit AI. Rest in peace, Petit AI. You will never be whipped again. No, no, no. Last whip. Bye bye. Rest in peace.